Imagine a place where the rules of the universe seem to bend, where light and darkness dance in ways we can barely comprehend. This is the Andromeda Galaxy's halo, a vast and mysterious region that stretches far beyond the galaxy's visible disk. Here, in this cosmic frontier, astronomers have uncovered some of the most bizarre and enigmatic objects ever observed. From ghostly nebulae to rogue black holes, the halo is a treasure trove of cosmic oddities that challenge our understanding of the universe. In this video, we'll take you on a journey through 50 of the strangest objects ever discovered in the Andromeda Galaxy's halo. Each one tells a story, raises new questions, and invites us to rethink what we know about the cosmos. So, are you ready to explore the unknown? Let's dive into the mysteries of the Andromeda Galaxy's halo and uncover the secrets hidden within its depths. Now, let's turn our attention to the first of these cosmic enigmas, a haunting presence in the Andromeda Galaxy's halo known as the Ghostly Nebula. This ethereal structure is unlike anything astronomers have encountered before. Unlike the vibrant, glowing nebulae we often picture, this one is faint, almost invisible, and seems to defy the usual classifications. Its wispy, ghost-like appearance has earned it its eerie name, and its discovery has left scientists both fascinated and puzzled. The Ghostly Nebula was first detected not through its light but through its shadow. Astronomers noticed an unusual dimming of background stars in a specific region of the halo. Upon closer inspection, they realized this dimming was caused by a massive, diffuse cloud of gas and dust, so faint that it barely emits any light of its own. This makes it incredibly difficult to study, as it doesn't glow like typical nebulae, which are often illuminated by nearby stars. Instead, the Ghostly Nebula seems to exist in a state of near invisibility, drifting silently through the halo. What makes this nebula truly stand out is its unusual structure. While most nebulae have distinct shapes like the swirling arms of a spiral or the jagged edges of a supernova remnant, the Ghostly Nebula appears almost formless. It stretches across vast distances with no clear boundaries or edges, as if it's dissolving into the surrounding space. Some scientists speculate that it might be the remnants of an ancient star that exploded long ago, scattering its material so thinly that it's now barely detectable. Others suggest it could be a relic from the early universe, a leftover fragment from the formation of the Andromeda Galaxy itself. The discovery of the Ghostly Nebula has raised intriguing questions about the nature of nebulae and the processes that shape them. Why does it lack the bright, glowing features we associate with other nebulae? What forces are at work in the halo that allow such a faint structure to persist? And could there be more of these ghostly clouds hidden in the depths of space, waiting to be discovered? As astronomers continue to study this mysterious object, it serves as a reminder of how much we still have to learn about the cosmos. With a Ghostly Nebula setting the stage, our journey into the Andromeda Galaxy's halo is just beginning. Next, we'll explore an even more perplexing phenomenon, a region where the very fabric of the universe seems to warp and twist. Stay with us as we uncover the secrets of the Dark Matter Anomaly. Now, let's venture deeper into the mysteries of the Andromeda Galaxy's halo, where we encounter something even more enigmatic than the Ghostly Nebula, a region known as the Dark Matter Anomaly. This peculiar area has baffled scientists for years, not because of what it shows, but because of what it hides. Here, in this seemingly empty patch of space, lies an unexplained concentration of dark matter, the invisible substance that makes up most of the universe's mass. Unlike the Ghostly Nebula, which we can at least detect through its faint shadow, the Dark Matter Anomaly reveals itself only through its gravitational effects, pulling on nearby stars and galaxies in ways that defy expectations. The significance of this anomaly cannot be overstated. Dark matter, by its very nature, is elusive. It doesn't emit, absorb, or reflect light, making it nearly impossible to observe directly. Yet its presence is felt everywhere, shaping the structure of galaxies and holding them together. In the Andromeda Galaxy's halo, this concentration of dark matter is unusually dense, far more than what current astrophysical models predict. This discrepancy challenges our understanding of how dark matter is distributed in the universe and raises questions about the forces that govern its behavior. One of the most puzzling aspects of the dark matter anomaly is its location. Dark matter is typically thought to form a diffuse halo around galaxies, spreading out evenly over vast distances. But in this region, it appears to clump together in a way that defies conventional theories. Some scientists speculate that this could be evidence of dark matter interacting with itself in ways we don't yet understand. Others suggest it might be a remnant of a cosmic collision, where two galaxies merged long ago, leaving behind a dense pocket of dark matter. What makes this discovery even more intriguing is what it might reveal about the nature of dark matter itself. For decades, scientists have been trying to uncover the true identity of this mysterious substance. Is it made up of particles we've yet to detect, or does it represent something entirely new, a form of matter that operates outside the laws of physics as we know them? The dark matter anomaly could hold the key to answering these questions, offering clues that might finally bring us closer to understanding one of the universe's greatest mysteries. As we continue to explore the Andromeda Galaxy's halo, the dark matter anomaly stands as a testament to how much we still have to learn about the cosmos. It challenges our assumptions, pushes the boundaries of our knowledge, and reminds us that the universe is far stranger and more complex than we can imagine. Next, we'll turn our attention to another ancient relic hidden in the halo, a star cluster that predates the galaxy itself. Stay with us as we uncover the secrets of the ancient star cluster. Moving deeper into the halo of the Andromeda Galaxy, we now encounter a celestial relic that seems to defy time itself, the ancient star cluster. This remarkable collection of stars is not just old, it's ancient, predating even the formation of the Andromeda Galaxy. Imagine a group of stars so old that they were shining long before the galaxy we see today even began to take shape. This cluster is a living fossil, offering us a rare glimpse into the early universe and the processes that shaped galaxies like Andromeda. The composition of the ancient star cluster is unlike anything we typically see in younger star clusters. It's made up of stars that are incredibly metal-poor, meaning they contain very few elements heavier than hydrogen and helium. This scarcity of metals is a telltale sign of their age. In the early universe, heavier elements like carbon, oxygen, and iron didn't exist yet. They were forged later in the hearts of stars and scattered across the cosmos by supernova explosions. The stars in this cluster, however, formed before these elements became abundant, making them some of the purest remnants of the universe's infancy. But how old is this cluster exactly? Astronomers estimate that the stars here are around 13 billion years old, making them nearly as old as the universe itself. To put that into perspective, our own sun is a mere 4.5 billion years old. These ancient stars have witnessed the birth and evolution of galaxies, surviving through eons of cosmic history. Their age challenges our understanding of galactic formation, suggesting that some structures in the universe may have formed much earlier than we once thought. The implications of this discovery are profound. If star clusters like this one existed before galaxies, it raises questions about how galaxies themselves came to be. Did galaxies form around these early clusters, or did they grow independently and later incorporate them? The ancient star cluster provides a unique opportunity to study the conditions of the early universe and test our theories about how galaxies assemble over time. It's like finding a piece of a puzzle that helps us see the bigger picture of cosmic evolution. What's even more fascinating is how this cluster has managed to survive for so long. Star clusters are often torn apart by the gravitational forces of their host galaxies, yet this one has endured. Its survival suggests that it may have formed in a relatively quiet corner of the early universe, away from the chaotic collisions and mergers that shaped later galaxies. This resilience makes it a rare and invaluable window into the past. As we continue to study the ancient star cluster, we're reminded that the universe is full of surprises. It challenges our assumptions, pushes the boundaries of our knowledge, and offers clues to questions we didn't even know to ask. Next, we'll turn our attention to a more ominous presence in the halo, a rogue black hole drifting silently through the void. Stay with us as we uncover the mysteries of this cosmic wanderer. Now, let's shift our gaze to a more ominous presence lurking in the halo of the Andromeda Galaxy, a rogue black hole. Unlike the black holes we're familiar with, which sit at the centers of galaxies, this one is a cosmic wanderer drifting silently through the vast expanse of the halo. Its discovery was no small feat. Astronomers detected it not by seeing it directly after all. Black holes are invisible, but by observing the gravitational effects it has on its surroundings. As it moves, it warps the fabric of space-time, bending light from distant stars and creating distortions that reveal its presence. The origins of this rogue black hole are shrouded in mystery. One theory suggests it was ejected from the core of a galaxy during a violent collision or merger. When galaxies collide, their central black holes can be flung out into space, sent hurtling through the cosmos like cosmic outcasts. Another possibility is that it formed in isolation, born from the collapse of a massive star in the early universe. Whatever its origins, this black hole is a reminder of the chaotic and unpredictable nature of the cosmos. But what makes this rogue black hole so dangerous? For one, its immense gravitational pull can disrupt the orbits of nearby stars and gas clouds. Any celestial body that ventures too close risks being torn apart or devoured entirely. Even more concerning is the potential for it to collide with other objects in the halo. A collision with a star or another black hole could release an enormous burst of energy, sending shockwaves through the surrounding space. While such events are rare, they remind us of the dynamic and sometimes perilous nature of the universe. Despite its dangers, the rogue black hole also offers a unique opportunity for scientific discovery. By studying its movement and interactions, astronomers can learn more about the behavior of black holes and the forces that shape the cosmos. It's a reminder that even the most mysterious and intimidating objects in the universe can teach us something new. As we continue our journey through the halo, we'll next explore a phenomenon that has puzzled astronomers for decades, a mysterious radio source emitting signals from the depths of space. Stay tuned as we unravel this cosmic enigma. Now, let's turn our attention to a phenomenon that has baffled scientists for decades, a mysterious radio source emanating from the depths of the Andromeda Galaxy's halo. Unlike the rogue black hole we just explored, this object doesn't rely on gravity to make its presence known. Instead, it broadcasts its existence through powerful bursts of radio waves, signals that have traveled across the cosmos to reach us. These waves are not random noise, they are structured, intense, and unlike anything else observed in the halo. The source of these radio waves remains one of the greatest mysteries in modern astronomy. What makes it so puzzling is its irregular pattern. Unlike pulsars, which emit regular, rhythmic pulses, this radio source is unpredictable. It flares up at random intervals, sometimes remaining silent for years before suddenly bursting back to life. This erratic behavior has made it incredibly difficult to study, leaving astronomers with more questions than answers. So, what could be causing these mysterious signals? One leading theory suggests that the source might be a highly magnetized neutron star known as a magnetar. These exotic objects are capable of producing immense bursts of energy, including radio waves, when their magnetic fields undergo sudden changes. However, the irregularity of the signals doesn't quite match what we know about magnetars, leaving room for doubt. Another possibility is that the source could be the result of a rare cosmic event, such as the collision of two neutron stars or the interaction of a black hole with a surrounding gas cloud. These events could produce short-lived but intense bursts of radio energy, explaining the sporadic nature of the signals. Yet, there's also a more speculative explanation, one that captures the imagination of both scientists and the public alike. Could this radio source be evidence of extraterrestrial intelligence? While this idea is intriguing, most astronomers remain skeptical. The signals, while unusual, don't exhibit the kind of deliberate patterns that would suggest an artificial origin. Still, the possibility, however remote, adds an extra layer of fascination to this cosmic mystery. What makes this radio source so important is not just its mystery, but what it represents. It challenges our understanding of the universe and reminds us that there are still phenomena out there that defy explanation. Every time it flares up, it offers astronomers a new opportunity to study it, to gather more data, and to inch closer to solving the puzzle. As we continue to explore the halo of the Andromeda Galaxy, this enigmatic radio source stands as a testament to the vastness and complexity of the cosmos. Next, we'll journey to a glowing gas cloud, an object that shines with unusual spectral lines and holds secrets about the chemistry of the halo. Stay with us as we uncover more of the galaxy's hidden wonders. Now, let's shift our gaze to a radiant spectacle in the Andromeda Galaxy's halo, a glowing gas cloud that defies expectations. This luminous object isn't just another wispy collection of cosmic dust and gas. It's a beacon of mystery, shining with spectral lines that have left scientists scratching their heads. Unlike typical gas clouds, which emit light in predictable patterns, this one glows with an unusual combination of colors and wavelengths, hinting at a composition that's far from ordinary. At the heart of this glowing cloud lies a mix of elements that challenge our understanding of the halo's chemistry. While most gas clouds in space are dominated by hydrogen and helium, this one contains traces of heavier elements like oxygen, nitrogen, and even carbon. These elements aren't just floating around aimlessly, they're interacting in ways that produce the cloud's distinctive glow. The spectral lines, which act like fingerprints for chemical elements, reveal a complex dance of energy and matter, suggesting processes that are still poorly understood. What makes this gas cloud truly unique is its structure. Unlike the diffuse, shapeless clouds we often see, this one has a more defined, almost filament-like appearance. These filaments are threaded with regions of intense brightness, where the gas is heated to extreme temperatures by nearby stars or other energetic sources. This heating causes the gas to emit light in specific wavelengths, creating the unusual spectral lines that have captured astronomers' attention. So, what could this glowing gas cloud tell us about the Andromeda Galaxy's halo? For one, it suggests that the halo is far more chemically diverse than we once thought. The presence of heavier elements points to a history of stellar activity where stars have lived, died, and scattered their remains across the galaxy. These elements, forged in the hearts of stars and expelled in supernova explosions, have found their way into the halo, enriching its chemistry and creating the conditions for this glowing cloud to form. But the story doesn't end there. The cloud's unusual spectral lines also hint at processes that are still unfolding. Some scientists speculate that the cloud could be a site of ongoing star formation, where pockets of gas are collapsing under their own gravity to birth new stars. Others suggest that it might be the aftermath of a cosmic collision, where two gas clouds collided and triggered a burst of energy, leaving behind this glowing remnant. Whatever the explanation, this glowing gas cloud is a reminder of the halo's dynamic nature. It's not just a static backdrop to the galaxy. It's a vibrant, ever-changing region where the building blocks of the universe are constantly being reshaped. As we continue to study this enigmatic object, we inch closer to unraveling the secrets of the Andromeda Galaxy's halo and the cosmic processes that shape it. Next, we'll explore a dramatic cosmic event, a pair of dwarf galaxies colliding within the halo. a spectacle that reveals the forces shaping the galaxy's structure. Stay tuned as we dive deeper into the wonders of the Andromeda Galaxy. Now, let's turn our attention to a cosmic dance of destruction and creation, a pair of dwarf galaxies colliding within the Andromeda Galaxy's halo. This isn't just a random encounter, it's a dramatic event that reveals the forces shaping the galaxy's structure and evolution. Dwarf galaxies, though small compared to their larger counterparts, pack a punch when they collide, and this particular pair is no exception. The collision itself is a slow-motion spectacle unfolding over millions of years. As these two dwarf galaxies spiral toward each other, their gravitational forces pull and twist their shapes, stretching out streams of stars and gas in long, luminous arcs. These tidal tails, as they're called, are like cosmic fingerprints marking the paths of the galaxies as they merge. The process is chaotic, but within that chaos lies the potential for something extraordinary: new stars. The collision triggers a burst of star formation, as the gas clouds within the dwarf galaxies compress and ignite under the immense gravitational forces. Regions of intense brightness begin to glow, signaling the birth of countless new stars. These stellar nurseries are hotspots of activity, where young, hot stars light up the surrounding gas, creating a dazzling display of cosmic fireworks. It's a reminder that even in the vastness of space, destruction often paves the way for creation. But the impact of this collision extends far beyond the immediate area. The merging of these dwarf galaxies sends ripples through the Andromeda Galaxy's halo, altering its structure and composition. The influx of new stars and gas enriches the halo, adding to its complexity and diversity. Over time, the remnants of the collision will settle, becoming part of the halo's fabric and contributing to its ongoing evolution. What makes this event particularly fascinating is what it tells us about the history of the Andromeda Galaxy. Dwarf galaxies are often considered the building blocks of larger galaxies, and their collisions provide clues about how galaxies like Andromeda grew to their current size. By studying this pair, astronomers can piece together the story of how Andromeda's halo came to be, tracing the origins of its stars and gas back to these ancient cosmic encounters. As we watch these dwarf galaxies merge, we're witnessing a snapshot of a process that has shaped the universe for billions of years. It's a testament to the dynamic nature of the cosmos, where even the smallest objects can have a profound impact. Next, we'll uncover another mystery of the halo, an invisible barrier that seems to defy the laws of physics. Stay with us as we continue our journey through the wonders of the Andromeda Galaxy. Now, let's shift our focus to something that seems almost like a cosmic force field, an invisible barrier within the Andromeda Galaxy's halo. This mysterious structure doesn't emit light or heat, yet it has a profound effect on the high-energy particles known as cosmic rays. Imagine a shield, unseen but powerful, bending and redirecting these particles as they travel through space. This invisible barrier challenges our understanding of how cosmic rays move and interact with their surroundings. The discovery of this barrier came as a surprise to astronomers. While studying the distribution of cosmic rays in the halo, they noticed something unusual, a region where the intensity of these particles dropped sharply. It was as if something was blocking or deflecting them. Further observations revealed that this wasn't a random fluctuation but a consistent pattern, suggesting the presence of an invisible structure. But what could it be? One leading theory suggests that this barrier might be linked to magnetic fields. Cosmic rays, which are charged particles, are highly sensitive to magnetic forces. If there's a region in the halo with an unusually strong or complex magnetic field, it could act like a shield, bending the paths of cosmic rays and preventing them from passing through. Another possibility is that this barrier is created by interactions between cosmic rays and dense clouds of gas or dark matter, which could scatter or absorb the particles. The implications of this discovery are significant. Cosmic rays play a crucial role in shaping the environments of galaxies, influencing star formation and even the chemistry of interstellar gas. If an invisible barrier can alter their movement, it could have far-reaching effects on the evolution of the Andromeda Galaxy's halo. Understanding this phenomenon could also shed light on similar structures in other galaxies, helping us piece together the larger puzzle of cosmic ray propagation across the universe. What makes this barrier particularly intriguing is its invisibility. Unlike stars or gas clouds, it doesn't emit any detectable radiation, making it a challenge to study. Astronomers rely on indirect methods, such as observing how cosmic rays behave around it, to map its properties. This adds an extra layer of mystery to an already enigmatic object. As we continue to explore the Andromeda Galaxy's halo, this invisible barrier reminds us that the universe is full of surprises, even in the places we least expect. Next, we'll turn our attention to a star racing through the halo at incredible speeds, a hypervelocity star with a story that's just as fascinating. Stay with us as we uncover more of the halo's secrets. Now, let's zoom in on a celestial speedster, a hypervelocity star racing through the Andromeda Galaxy's halo at breathtaking speeds. This star isn't just moving fast, it's traveling so quickly that it defies the typical gravitational pull of the galaxy itself. But how did it get here, and what forces could have launched it on such a high-speed journey? Hypervelocity stars are rare and fascinating objects. They move at speeds exceeding hundreds of kilometers per second, fast enough to escape the gravitational grasp of their home galaxy. In the case of this particular star, astronomers believe its incredible velocity might be the result of a dramatic cosmic event. One leading theory suggests that it was once part of a binary star system, a pair of stars orbiting each other. When one of the stars exploded as a supernova, the sudden release of energy could have catapulted its companion star outward at an astonishing speed, sending it hurtling through the halo. Another possibility is that this star had a close encounter with the supermassive black hole at the center of the Andromeda Galaxy. The immense gravitational forces near such a black hole can act like a slingshot, flinging stars out into the galaxy's outskirts at incredible velocities. This process, known as a gravitational slingshot, could explain how this star ended up traveling so fast. The trajectory of this hypervelocity star is equally intriguing. Unlike most stars which follow predictable orbits within the galaxy, this one is on a one-way trip out of the halo. Its path takes it through regions of space that are sparsely populated, making it a lone traveler in the vast expanse of the galaxy's outer reaches. As it moves, it leaves behind a faint trail of light, a testament to its incredible journey. Studying hypervelocity stars like this one provides valuable insights into the dynamics of galaxies. They serve as cosmic probes, helping astronomers map the gravitational fields and dark matter distribution within the halo. By tracing their paths, scientists can learn more about the forces that shape galaxies and the events that can propel stars to such extreme speeds. What makes this star even more remarkable is its rarity. Hypervelocity stars are not common, and each one offers a unique opportunity to study the extreme conditions that can exist in the universe. As we continue to explore the Andromeda Galaxy's halo, this star reminds us that even the most familiar cosmic environments can hold extraordinary surprises. Next, we'll turn our attention to a mysterious object that might just be a rogue planet drifting through the halo. A phantom planet with a story that's as elusive as it is intriguing. Stay with us as we uncover more of the halo's secrets. Now, let's shift our gaze to a shadowy wanderer in the Andromeda Galaxy's halo, a phantom planet that defies easy detection. This mysterious object, believed to be a rogue planet, was discovered through a phenomenon known as gravitational microlensing. Unlike planets that orbit stars, this one drifts freely through the vast expanse of space, untethered to any solar system. Its discovery has sparked both excitement and intrigue, as it challenges our understanding of planetary formation and distribution. Gravitational microlensing occurs when a massive object like this rogue planet passes in front of a distant star. The planet's gravity bends and magnifies the star's light, creating a temporary brightening that astronomers can detect. It's through this subtle yet powerful effect that the phantom planet revealed itself. What makes this discovery so remarkable is the sheer difficulty of spotting such objects. Rogue planets emit no light of their own, and their presence can only be inferred through these fleeting cosmic alignments. Estimates suggest this phantom planet is massive, possibly several times the size of Jupiter. Yet, despite its size, it remains elusive. Without a host star to illuminate it, the planet is shrouded in darkness, making it nearly invisible to traditional observation methods. This raises fascinating questions about its origins. Was it ejected from a young solar system during a chaotic period of planetary formation? Or did it form independently, born from a collapsing cloud of gas and dust in the cold, dark regions of the halo? The mystery deepens when we consider how many more rogue planets might exist in the Andromeda Galaxy's halo. Current theories suggest they could number in the billions, far outnumbering stars. Yet, their solitary nature makes them incredibly difficult to study. Each discovery, like this one, offers a rare glimpse into a hidden population of celestial nomads drifting silently through the cosmos. What's even more intriguing is the potential for these rogue planets to host life. While they lack the warmth of a star, some scientists speculate that internal heat or tidal forces from nearby moons could create habitable conditions beneath their surfaces. Though this remains speculative, it opens up exciting possibilities for the search for life beyond Earth. As we continue to explore the Andromeda Galaxy's halo, this phantom planet serves as a reminder of how much we still have to learn about the universe. Its discovery not only challenges our understanding of planetary systems, but also hints at the countless other mysteries waiting to be uncovered in the vast, uncharted regions of space. Next, we'll delve into an even more enigmatic phenomenon, a cosmic string that might exist in the halo, stretching the boundaries of our understanding of physics. Stay tuned as we unravel this extraordinary mystery. Now, let's turn our attention to one of the most mind-bending concepts in the Andromeda Galaxy's halo, a cosmic string. This theoretical object, if it exists, would stretch the limits of our understanding of physics and the universe itself. Cosmic strings are hypothetical one-dimensional structures, remnants of the early universe, that could stretch across vast distances, even spanning entire galaxies. Imagine them as incredibly thin, yet unimaginably dense threads, thinner than an atom but with the mass of a mountain. Their existence would be a direct consequence of the extreme conditions that followed the Big Bang, offering a glimpse into the universe's infancy. The idea of cosmic strings stems from theories in particle physics and cosmology, particularly those involving symmetry breaking in the early universe. As the universe cooled and expanded, phase transitions occurred, much like water freezing into ice. These transitions could have created defects in the fabric of space-time, giving rise to cosmic strings. If they exist, they would be incredibly stable, persisting for billions of years and potentially influencing the structure of the cosmos on a grand scale. Detecting a cosmic string is no easy task. Unlike stars or planets, they don't emit light or other forms of radiation. Instead, their presence would be inferred through their gravitational effects. One way to spot them is by observing the distortion they cause in the light from distant objects. As light passes near a cosmic string, its path would be bent, creating a phenomenon known as gravitational lensing. This would result in double images of the same object appearing side by side in the sky. Another potential signature is the emission of gravitational waves, ripples in space-time caused by the string's vibrations or interactions. Despite their theoretical appeal, cosmic strings remain speculative. No direct evidence of their existence has been found, and their detection would require incredibly precise observations. However, their discovery would revolutionize our understanding of the universe. They could provide insights into the fundamental forces of nature, the conditions of the early universe, and even the nature of space-time itself. Some theories even suggest that cosmic strings could act as cosmic highways, enabling faster than light travel, though this remains firmly in the realm of science fiction for now. The search for cosmic strings is a testament to humanity's curiosity and determination to uncover the universe's deepest secrets. While they remain elusive, their potential existence reminds us that the cosmos is full of wonders waiting to be discovered. As we continue to explore the Andromeda Galaxy's halo, the possibility of finding a cosmic string keeps the flame of discovery alive, pushing the boundaries of what we know and what we dare to imagine. Next, we'll explore another mysterious phenomenon in the halo, a sudden and unexplained flare of light that has left astronomers scratching their heads. Stay with us as we dive into this intriguing cosmic puzzle. Now, let's shift our focus to a phenomenon that has left astronomers both fascinated and baffled, a sudden and unexplained flare of light in the Andromeda Galaxy's halo. This mysterious burst of energy appeared without warning, shining brighter than anything else in its vicinity before vanishing just as quickly. The flare's brief but intense presence has sparked countless theories, yet its true nature remains one of the halo's most intriguing unsolved mysteries. One of the leading explanations for this flare is a stellar collision. When two stars collide, the resulting explosion can release an enormous amount of energy, creating a brilliant flash of light. Such events are rare, but they do occur, especially in densely populated regions like the halo. However, the timing and intensity of this particular flare don't quite match what we'd expect from a typical stellar collision, leaving scientists to wonder if something even more extraordinary might be at play. Another possibility is that the flare was caused by a supernova, a massive star reaching the end of its life and exploding in a spectacular display. Supernova are some of the most energetic events in the universe, capable of outshining entire galaxies for a short time. Yet, even this explanation falls short. The flare didn't exhibit the usual afterglow or debris that supernova leave behind, making it an unlikely candidate. Some astronomers have proposed more exotic explanations, such as the interaction of a black hole with a nearby star or gas cloud. When matter falls into a black hole, it can heat up and emit intense bursts of radiation. Alternatively, the flare could be the result of a rare cosmic event, like the merger of two neutron stars, which produces both light and gravitational waves. While these theories are compelling, they remain speculative without more evidence. What makes this flare particularly puzzling is its sudden appearance and disappearance. Unlike other cosmic events, which often leave behind traces or evolve over time, this flare seemed to come out of nowhere and vanish just as quickly. This has led some to consider even more unconventional ideas, such as the possibility of advanced extraterrestrial activity. While this idea captures the imagination, it's important to note that there's no concrete evidence to support it, and most scientists remain focused on natural explanations. The unidentified flare serves as a reminder of how much we still have to learn about the universe. Despite our advanced technology and growing knowledge, there are phenomena that defy our current understanding. Each new discovery, even one as fleeting as this flare, pushes us to refine our theories and expand our horizons. As we continue our journey through the Andromeda Galaxy's halo, the mystery of this flare reminds us that the cosmos is full of surprises. Next, we'll explore another enigmatic feature, a region with an unusually strong magnetic field that challenges our understanding of galactic halos. Stay tuned as we uncover more of the universe's secrets. Moving deeper into the mysteries of the Andromeda Galaxy's halo, we now encounter a phenomenon that defies our expectations, a region with an unusually strong magnetic field. This magnetic anomaly is unlike anything observed in typical galactic halos, where magnetic fields are usually weak and diffuse. Here, the magnetic field is so intense that it influences the behavior of nearby objects, creating a cosmic environment that challenges our understanding of how such fields form and evolve. The effects of this magnetic anomaly are profound. Charged particles such as cosmic rays and interstellar gas are forced to follow the magnetic field lines, creating intricate patterns of movement. This can lead to the formation of shock waves and turbulence, which in turn affect star formation and the distribution of matter in the halo. The anomaly also acts as a barrier, deflecting high-energy particles and altering the paths of cosmic rays as they travel through the galaxy. These interactions provide a unique laboratory for studying the interplay between magnetic fields and cosmic phenomena. What makes this region particularly puzzling is the source of its magnetic field. In most cases, magnetic fields in galaxies are generated by the motion of charged particles within stars, gas clouds, and other structures. However, the strength and scale of this anomaly suggest a different origin. Some scientists propose that it could be the result of a past galactic collision, where the merging of two galaxies amplified the magnetic field to extraordinary levels. Others speculate that it might be linked to the presence of dark matter, which could interact with magnetic fields in ways we don't yet fully understand. The existence of this magnetic anomaly raises important questions about the nature of galactic halos. Traditionally, halos were thought to be relatively quiet regions with weak magnetic fields and little activity. This discovery challenges that assumption, suggesting that halos can host dynamic and complex magnetic environments. It also highlights the need for more advanced observations and simulations to unravel the mechanisms behind such phenomena. As we continue to explore the Andromeda Galaxy's halo, this magnetic anomaly serves as a reminder of the universe's capacity to surprise us. It pushes us to rethink our models and theories, encouraging us to look beyond what we think we know. Next, we'll turn our attention to another enigmatic object, a star that vanished without a trace, leaving astronomers with more questions than answers. Stay with us as we uncover more of the cosmos's hidden secrets. Now, let's shift our gaze to one of the most baffling mysteries in the Andromeda Galaxy's halo, a star that simply vanished. This disappearing star, once a bright and stable presence, left astronomers scratching their heads when it disappeared without a trace. Unlike stars that fade or explode in supernova, this one seemed to vanish as if it had never existed, leaving behind no debris, no light, and no explanation. One of the leading theories suggests that the star may have been consumed by a black hole. Black holes, with their immense gravitational pull, are capable of swallowing entire stars, leaving little to no evidence behind. If this star wandered too close to a black hole, it could have been torn apart and pulled into the void, disappearing from our view entirely. However, this explanation raises questions, as such an event would typically produce detectable gravitational waves or a burst of radiation, neither of which were observed in this case. Another intriguing possibility is that the star collapsed directly into a black hole without the usual fanfare of a supernova. This rare phenomenon, known as a failed supernova, occurs when a massive star's core collapses under its own gravity, bypassing the explosive stage and forming a black hole in near silence. While this could explain the star's sudden disappearance, it remains a speculative theory, as such events are incredibly difficult to detect and confirm. Some have even ventured into more speculative territory, suggesting that the star's disappearance could be linked to advanced extraterrestrial civilizations. The idea is that a highly advanced society might harness the energy of a star, perhaps by constructing a Dyson sphere or similar megastructure, effectively cloaking the star from our view. While this theory captures the imagination, it lacks concrete evidence and remains firmly in the realm of science fiction for now. What makes this disappearing star so perplexing is the absence of any clear explanation. Unlike other cosmic phenomena which leave behind clues or remnants, this star's vanishing act offers no tangible evidence to study. It challenges our understanding of stellar life cycles and forces us to consider possibilities that stretch the boundaries of current astrophysical knowledge. As we ponder the fate of this enigmatic star, it serves as a reminder of how much we still have to learn about the universe. The Andromeda Galaxy's halo continues to surprise us, offering mysteries that defy easy answers and inspire us to keep exploring. Next, we'll turn our attention to another fascinating feature, a filament of the cosmic web, a thread that connects the galaxy to the larger structure of the universe. Stay with us as we unravel more of the cosmos's hidden wonders. Now, let's journey into the intricate tapestry of the cosmos, where we encounter a remarkable thread weaving through the Andromeda Galaxy's halo, a filament of the cosmic web. This delicate structure, often described as the universe's skeleton, is a vast network of gas and dark matter that connects galaxies across unimaginable distances. It's a glimpse into the grand architecture of the universe, revealing how everything is interconnected on the largest scales. The cosmic web filament in Andromeda's halo is a crucial piece of this cosmic puzzle. These filaments act as highways, channeling gas and matter between galaxies and galaxy clusters, fueling star formation and shaping the evolution of the universe. What makes this particular filament so fascinating is its role in linking Andromeda to the broader cosmic network. It's not just a random strand of gas, it's a vital conduit that ties the galaxy to its neighbors and beyond. Detecting such filaments is no small feat. They are faint and diffuse, often invisible to traditional telescopes. Astronomers rely on advanced techniques, such as mapping the distribution of galaxies and analyzing the subtle distortions of light caused by gravitational lensing, to trace these elusive structures. The discovery of this filament in Andromeda's halo is a testament to the ingenuity of modern astrophysics, offering a rare window into the universe's hidden framework. But why does this matter? The cosmic web filament provides critical insights into the large-scale structure of the universe. It helps us understand how matter is distributed and how galaxies form and evolve over billions of years. By studying these filaments, scientists can piece together the history of cosmic expansion and the role of dark matter in shaping the universe. It's like uncovering the blueprints of existence itself, revealing the forces that have shaped everything we see. This filament also raises intriguing questions about the nature of the universe. How do these structures form and evolve? What role do they play in the birth of galaxies? And how do they influence the flow of matter and energy across the cosmos? Each discovery brings us closer to answering these profound questions, deepening our understanding of the universe's intricate design. As we marvel at this cosmic thread, we're reminded of the interconnectedness of all things. The Andromeda Galaxy, our own Milky Way, and every star and planet are part of this vast, intricate web. It's a humbling perspective, one that underscores the beauty and complexity of the universe. Next, we'll turn our attention to another enigmatic feature, a structure that some believe could be artificial. Stay with us as we explore the mysteries of the Andromeda Galaxy's halo and the wonders it holds. Now, shifting our gaze to another captivating mystery, we encounter an object that has sparked both scientific curiosity and wild speculation, the so-called alien megastructure. Nestled within the Andromeda Galaxy's halo, this enigmatic formation has left astronomers and enthusiasts alike wondering if it could be evidence of extraterrestrial engineering. While the idea of an alien-built structure may sound like science fiction, the peculiar characteristics of this object have made it a topic of serious debate. The alien megastructure, as it's informally called, was first detected through unusual patterns of light dimming and brightening. Unlike typical celestial objects, which dim in predictable ways, this structure exhibits irregular and seemingly artificial fluctuations. Some researchers have proposed that these patterns could be caused by a massive artificial construct, such as a Dyson sphere, a hypothetical megastructure designed to harness energy from a star. While this idea is tantalizing, it's important to note that it remains speculative and highly controversial. Alternative explanations for the structure's behavior have also been put forward. One possibility is that it's a natural phenomenon, such as a swarm of comets or a dense cloud of interstellar dust, passing in front of a star and causing the unusual light patterns. Another theory suggests it could be the result of gravitational microlensing, where the gravity of a massive object bends and distorts light from a background star. These natural explanations are more widely accepted within the scientific community, but the allure of the alien megastructure hypothesis continues to captivate the public's imagination. What makes this object so fascinating is not just its mysterious nature, but also the questions it raises about our place in the universe. If such a structure were artificial, it would imply the existence of an advanced civilization capable of engineering on a cosmic scale. This idea taps into humanity's enduring fascination with the possibility of extraterrestrial life and our desire to find evidence of intelligence beyond Earth. It's a reminder of how much we still have to learn about the cosmos and the potential for discoveries that could fundamentally change our understanding of existence. The alien megastructure has also become a cultural phenomenon, inspiring countless discussions, articles, and even works of fiction. Its blend of scientific intrigue and speculative wonder makes it a perfect example of how space exploration captures our collective imagination. Whether it's a natural anomaly or something more extraordinary, this object challenges us to think beyond the boundaries of what we know and to consider the vast possibilities that lie hidden in the depths of space. As we continue our journey through the Andromeda Galaxy's halo, we'll next explore another remnant of cosmic violence, a supernova remnant with properties that defy expectations. Stay with us as we uncover more of the galaxy's secrets and the stories they tell. Now, turning our attention to another remarkable feature of the Andromeda Galaxy's halo, we encounter a supernova remnant that defies the ordinary. This cosmic relic, the result of a star's explosive death, stands out not just for its dramatic origins, but for the unusual properties that make it a subject of intense study. Unlike typical supernova remnants which fade into obscurity over time, this one continues to reveal secrets that challenge our understanding of stellar life cycles. Estimated to be around 10,000 years old, this supernova remnant is relatively young in cosmic terms, yet its composition is anything but typical. Most remnants are composed of heavy elements forged in the heart of the dying star, but this one contains an unusually high concentration of rare isotopes and metals, such as titanium and nickel. These elements, typically found in smaller quantities, suggest that the original star may have been part of a rare class of supermassive stars with unique chemical processes. The presence of these materials has provided astronomers with a rare opportunity to study the conditions under which such elements are created and dispersed into the cosmos. What truly sets this remnant apart, however, is its structure. While most supernova remnants expand uniformly, this one exhibits an asymmetrical shape, with dense knots of material clustered in one region and a faint, wispy tail extending in the opposite direction. This irregularity has led scientists to speculate that the explosion may have been influenced by external factors, such as a nearby black hole or a dense interstellar medium. The remnant's unusual morphology has also sparked debates about whether it could be the result of a rare type of supernova, such as a pair instability supernova, which occurs in extremely massive stars and produces dramatically different outcomes compared to standard supernova. The study of this supernova remnant has broader implications for our understanding of galactic evolution. By analyzing its composition and structure, researchers can gain insights into how heavy elements are distributed throughout galaxies, contributing to the formation of new stars and planets. It also serves as a reminder of the violent processes that shape the universe, highlighting the delicate balance between creation and destruction in the cosmos. As we move forward in our exploration of the Andromeda Galaxy's halo, we'll next delve into an object that challenges our understanding of light itself, a star that emits almost no visible light. Stay with us as we uncover more of the galaxy's hidden wonders and the mysteries they hold. Shifting our gaze to another enigmatic object in the Andromeda Galaxy's halo, we encounter a celestial oddity that defies conventional expectations, a star that emits almost no visible light. Known as a dark star, this mysterious object challenges our understanding of stellar evolution and raises questions about the nature of stars that exist in the shadows of the cosmos. The discovery of this dark star was no small feat. Unlike typical stars that shine brightly across the electromagnetic spectrum, this one remained hidden for decades, detectable only through its faint infrared emissions and subtle gravitational influence on nearby objects. Astronomers first noticed its presence while studying the halo's faint background radiation, where they detected an unusual source of heat that didn't correspond to any known star or nebula. Further observations revealed that this object was in fact a star, but one that emitted almost no visible light, making it nearly invisible to traditional telescopes. So, what makes this star so dark? Current theories suggest that its lack of visible light could be due to an unusually thick layer of cosmic dust surrounding it, absorbing most of the light it emits. Alternatively, it might be a type of failed star, such as a brown dwarf, that never accumulated enough mass to ignite sustained nuclear fusion. However, this dark star appears to be more massive than typical brown dwarfs, hinting at a more exotic explanation. Some scientists speculate that it could be a remnant of an ancient star that has cooled and dimmed over billions of years, or even a new class of stellar object that we have yet to fully understand. The composition of this dark star adds another layer of intrigue. Initial spectroscopic analysis suggests it contains an unusually high concentration of heavy elements, such as carbon and silicon, which are typically found in older stars. This raises questions about its origins. Could it have formed in a region of the halo rich in these elements, or did it accumulate them over time through interactions with other celestial bodies? The answers to these questions could reshape our understanding of how stars form and evolve in the unique environment of a galactic halo. What makes this dark star particularly challenging to our understanding of stellar evolution is its very existence. Stars are, by definition, luminous objects powered by nuclear fusion, so the idea of a star that emits almost no visible light contradicts our current models. Its discovery forces us to reconsider the boundaries of what constitutes a star and opens up new avenues for exploring the diversity of stellar objects in the universe. As we continue our journey through the Andromeda Galaxy's halo, we'll next explore an object that bends the very fabric of space and time, a natural gravitational lens. Stay with us as we uncover more of the galaxy's hidden wonders and the mysteries they hold. Now, let's turn our attention to a phenomenon that bends the very fabric of space and time, a natural gravitational lens nestled within the Andromeda Galaxy's halo. This extraordinary object acts like a cosmic magnifying glass, warping the light from distant galaxies and allowing us to peer deeper into the universe than ever before. Gravitational lenses are among the most powerful tools in astronomy, and this one in Andromeda's halo is no exception. The discovery of this gravitational lens came as a surprise during a routine survey of the halo's faint background light. Astronomers noticed that light from a distant galaxy appeared distorted, stretched into a faint arc around a massive object in the foreground. Further analysis revealed that the distortion was caused by the immense gravitational pull of a dense cluster of stars and dark matter within the halo. This cluster's gravity was so strong that it bent the light passing near it, creating a natural lens effect. This phenomenon, predicted by Einstein's theory of general relativity, allows us to observe objects that would otherwise be too faint or distant to detect. So, how does this gravitational lens work? Imagine space as a vast, flexible sheet. When a massive object like a star cluster sits on this sheet, it creates a deep well, bending the fabric of space around it. Light traveling near this well follows the curve, effectively magnifying and distorting the images of objects behind it. In the case of this lens in Andromeda's halo, it magnifies the light from galaxies billions of light years away, giving us a clearer view of the early universe. This magnification effect has allowed astronomers to study the formation of galaxies, the distribution of dark matter, and even the rate of the universe's expansion with unprecedented precision. The importance of this gravitational lens extends far beyond its ability to magnify distant objects. It also provides a unique window into the distribution of dark matter within the halo. By analyzing how the lens distorts light, scientists can map the invisible dark matter that makes up a significant portion of the halo's mass. This information is crucial for understanding how galaxies like Andromeda form and evolve over time. Additionally, the lens has been used to study some of the earliest galaxies in the universe, offering insights into the conditions of the cosmos just a few 100 million years after the Big Bang. What makes this gravitational lens particularly fascinating is its role in testing our understanding of gravity itself. By observing how light bends around the lens, astronomers can verify the predictions of general relativity on cosmic scales. So far, the observations align perfectly with Einstein's theory, but even the smallest discrepancies could hint at new physics waiting to be discovered. As we continue our exploration of the Andromeda Galaxy's halo, we'll next delve into a region that produces an unusually high number of cosmic rays, a cosmic ray factory. Stay tuned as we uncover more of the galaxy's hidden wonders and the secrets they hold. Now, shifting our gaze to another enigmatic feature of the Andromeda Galaxy's halo, we encounter a region that acts as a cosmic ray factory. This area is a hotbed of high-energy particles, producing an extraordinary number of cosmic rays that ripple through space. Cosmic rays are charged particles, primarily protons and atomic nuclei, that travel at nearly the speed of light. But what makes this region in Andromeda's halo so prolific in generating them? Let's dive into the mysteries behind this cosmic phenomenon. The origins of these cosmic rays are still a subject of intense study, but astronomers have identified several potential sources. One leading theory points to supernova, the explosive deaths of massive stars. When a star goes supernova, it releases an immense amount of energy, accelerating particles to incredible speeds and launching them into space. These particles then become cosmic rays, traveling across vast distances. Another possibility involves exotic particles or interactions within the halo itself, such as the annihilation of dark matter particles, which could produce high-energy radiation and cosmic rays as a byproduct. What makes this region particularly intriguing is its ability to produce cosmic rays at a rate far exceeding what we observe in other parts of the galaxy. This suggests that something extraordinary is happening here, whether it's an unusually high concentration of supernova remnants, a unique magnetic field structure, or even interactions with dark matter. The implications for astrophysics are profound. By studying this cosmic ray factory, scientists can gain insights into the processes that accelerate particles to such extreme energies, shedding light on the fundamental forces at work in the universe. Cosmic rays also play a crucial role in shaping the environment of the galaxy. As they travel through space, they interact with gas, dust, and magnetic fields, influencing the formation of stars and even the chemistry of interstellar material. In the Andromeda Galaxy's halo, this cosmic ray factory could be a key player in regulating the halo's dynamics and its interactions with the surrounding intergalactic medium. Understanding this region could help us piece together how galaxies evolve over time and how cosmic rays contribute to the larger cosmic ecosystem. As we continue to explore the Andromeda Galaxy's halo, this cosmic ray factory stands as a testament to the incredible energy and complexity hidden within the cosmos. Next, we'll turn our attention to a stream of gas flowing between galaxies, revealing yet another layer of the halo's intricate structure. Stay with us as we uncover more of the galaxy's secrets and the wonders they hold. Now, let's journey into the next fascinating feature of the Andromeda Galaxy's halo, a mysterious intergalactic gas stream. Picture this, a vast river of gas flowing silently through the void, connecting galaxies like an invisible thread in the cosmic tapestry. This gas stream is not just a random feature, it's a dynamic and vital part of the halo's structure, playing a key role in shaping the galaxy's evolution. The origins of this intergalactic gas stream are as intriguing as the stream itself. Astronomers believe it could be the remnants of ancient galactic interactions. When galaxies collide or pass close to one another, they can pull gas from each other, stretching it out into long, flowing streams. Over billions of years, these streams can persist, weaving through the halo and carrying with them the raw materials needed for star formation. Another possibility is that the stream originates from the galaxy itself, ejected by powerful events like supernova explosions or the activity of supermassive black holes. These processes can propel gas out into the halo, where it eventually forms these intergalactic rivers. The composition of this gas stream is equally fascinating. It's primarily made up of hydrogen, the most abundant element in the universe, along with traces of heavier elements like helium, carbon, and oxygen. These elements are crucial for the formation of stars and planets, making the stream a potential reservoir of future cosmic building blocks. What's more, the gas is often ionized, meaning its atoms have lost or gained electrons, giving it unique properties that allow it to interact with magnetic fields and other cosmic forces. But how does this gas stream contribute to the halo's dynamics? For one, it acts as a conveyor belt transporting material across vast distances. This movement can influence the distribution of gas within the halo, affecting where and how new stars form. The stream also interacts with other structures in the halo, such as dark matter and cosmic rays, creating a complex web of interactions that shape the galaxy's environment. In some cases, the gas stream may even feed into the galaxy itself, replenishing its supply of star-forming material and influencing its growth over time. The intergalactic gas stream is a reminder of the interconnectedness of the cosmos. It shows us that galaxies are not isolated islands but part of a larger, dynamic system where gas, stars, and dark matter are constantly in motion. By studying this stream, scientists can gain insights into the processes that drive galactic evolution and the role of gas in shaping the universe as we know it. As we move forward, our exploration of the Andromeda Galaxy's halo takes us to another extraordinary phenomenon, an echo of a long-dead quasar, a relic from the galaxy's distant past. Stay with us as we uncover more of the mysteries hidden within this vast and enigmatic region. Now, let's turn our attention to a ghostly whisper from the past, the quasar echo. This remarkable phenomenon is a faint but powerful reminder of a time when the Andromeda Galaxy was a very different place. Quasars, the incredibly bright cores of distant galaxies powered by supermassive black holes, once lit up the early universe. Though the quasar that created this echo has long since faded, its light continues to reverberate through the halo, offering us a glimpse into the galaxy's ancient history. The quasar echo was detected through a combination of advanced telescopes and meticulous analysis of light patterns. Astronomers noticed an unusual glow in the halo, one that didn't match the light from stars or gas clouds. Instead, it appeared to be the scattered remnants of light that had traveled billions of years to reach us. By studying the spectrum of this light, scientists were able to trace its origin back to a quasar that once shone brightly in the early universe. This echo is essentially a cosmic fossil, preserving the light of a quasar that has long since vanished. The age of this quasar echo is staggering. It dates back to a time when the Andromeda Galaxy was still in its infancy, forming from the swirling clouds of gas and dust that filled the early universe. The light we see today began its journey over 10 billion years ago, making this echo one of the oldest features in the halo. By studying it, astronomers can piece together the conditions of the early universe and understand how galaxies like Andromeda evolved over time. What makes this quasar echo particularly fascinating is what it reveals about the history of the Andromeda Galaxy. The presence of such an echo suggests that the galaxy's halo has been a dynamic and active region for billions of years. It tells us that quasars, though rare today, were once common in the universe, and their intense radiation played a crucial role in shaping the environments of early galaxies. The echo also provides clues about the distribution of gas and dust in the halo, helping scientists understand how these materials have been recycled over cosmic time. As we continue to explore the Andromeda Galaxy's halo, the quasar echo stands as a testament to the enduring mysteries of the cosmos. It reminds us that even the faintest traces of light can carry profound stories about the universe's past. Next, we'll delve into another extraordinary feature of the halo, a dense cluster of neutron stars, where the remnants of massive stellar explosions come together in a cosmic dance. Stay with us as we uncover more of the secrets hidden within this vast and enigmatic region. Now, let's shift our gaze to one of the most extreme environments in the Andromeda Galaxy's halo, a dense cluster of neutron stars. These remnants of massive stellar explosions are packed together in a cosmic dance, creating a region of incredible density and energy. Neutron stars are the collapsed cores of stars that once burned brightly before ending their lives in spectacular supernova. What remains is an object so dense that a single teaspoon of its material would weigh billions of tons on Earth. This cluster, however, is not just a random gathering of neutron stars. It's a tightly bound group formed through a combination of gravitational interactions and the remnants of ancient star-forming regions. As massive stars in a cluster exhaust their fuel and explode as supernova, their cores collapse into neutron stars. Over time, these neutron stars are drawn together by gravity, forming a dense cluster that can contain dozens or even hundreds of these exotic objects. Studying this neutron star cluster is no easy task. Neutron stars are incredibly small, typically only about 12 miles across, making them difficult to observe directly. Instead, astronomers rely on the radiation they emit, particularly in the form of X-rays and radio waves. The intense magnetic fields and rapid rotation of neutron stars create powerful beams of radiation that sweep across space like cosmic lighthouses. By detecting these pulses, scientists can map the locations and movements of neutron stars within the cluster. The challenges don't end there. The extreme gravitational forces within the cluster can warp space-time, creating conditions that are difficult to model and understand. Additionally, the interactions between neutron stars can lead to collisions, which produce some of the most energetic events in the universe, such as gamma-ray bursts and gravitational waves. These collisions are rare but provide invaluable insights into the behavior of matter under the most extreme conditions. What makes this neutron star cluster so significant is what it tells us about the life cycle of stars and the evolution of galaxies. By studying these stellar remnants, astronomers can piece together the history of star formation and death in the Andromeda Galaxy. The cluster also serves as a natural laboratory for testing theories about the behavior of matter at densities far beyond anything we can recreate on Earth. As we continue to explore the Andromeda Galaxy's halo, this neutron star cluster stands as a testament to the incredible forces at work in the universe. It reminds us that even in the aftermath of stellar destruction, there is beauty and mystery to be found. Next, we'll turn our attention to another fascinating object in the halo, a ring of cosmic dust surrounding a star where the building blocks of planets and moons come together in a delicate dance. Stay with us as we uncover more of the secrets hidden within this vast and enigmatic region. Now, let's journey to a quieter but no less fascinating corner of the Andromeda Galaxy's halo, where we encounter a delicate and mesmerizing structure, a ring of cosmic dust encircling a star. This cosmic dust ring is a stunning example of how the remnants of stellar evolution can come together to form something truly extraordinary. Unlike the chaotic environments of neutron star clusters or the explosive remnants of supernova, this ring represents a more serene yet equally important process in the life cycle of stars and planetary systems. The ring is composed of tiny particles of dust, primarily made up of silicates, carbon compounds, and ice. These particles are the leftover debris from the formation of the star itself, as well as the remnants of collisions between asteroids, comets, and other small bodies in the star's vicinity. Over time, gravitational forces and radiation pressure from the star have shaped this debris into a thin, flat ring that orbits at a precise distance. This ring is not just a random scattering of dust, it's a carefully balanced structure where the forces of gravity and light work together to maintain its shape. What makes this cosmic dust ring particularly unique is its role as a cosmic nursery. Within this ring, the dust particles collide and stick together, gradually forming larger and larger clumps. Over millions of years, these clumps can grow into planetesimals, the building blocks of planets and moons. In many ways, this ring is a snapshot of the early stages of planetary formation, offering astronomers a glimpse into how solar systems like our own might have begun. The star at the center of this ring is relatively young, and its dust ring provides a rare opportunity to study the processes that lead to the birth of planets. The formation of this ring is also a testament to the delicate balance of forces in the universe. The star's radiation pushes the dust particles outward, while its gravity pulls them inward. This interplay creates a stable orbit for the dust, allowing it to settle into a ring rather than dispersing into space or collapsing into the star. The ring's composition and structure can vary depending on the star's age, temperature, and the history of collisions within its system. Some rings may contain more ice, while others are dominated by rocky material, each telling a different story about the star and its surroundings. What sets this cosmic dust ring apart from others in the Andromeda Galaxy's halo is its pristine condition. Many such rings are disrupted by nearby stars, gravitational interactions, or the passage of time, but this one remains remarkably intact. Its stability and clarity make it an ideal laboratory for studying the early stages of planetary formation and the dynamics of dust in space. By observing the light that passes through the ring, astronomers can analyze its composition, density, and even the size of its particles, providing valuable insights into the processes that shape planetary systems. As we marvel at this cosmic dust ring, we're reminded of the intricate and interconnected nature of the universe. From the tiniest dust particles to the formation of entire planets, every element plays a role in the grand tapestry of cosmic evolution. This ring is not just a beautiful sight. It's a window into the past and a clue to understanding how the building blocks of life come together in the vastness of space. Next, we'll explore another enigmatic object in the halo, a remnant of one of the most powerful explosions in the universe, a gamma-ray burst. Stay with us as we continue to uncover the mysteries of the Andromeda Galaxy's halo. Now, shifting our gaze to a phenomenon of unimaginable power, we encounter the remnants of a gamma-ray burst, one of the most energetic events in the universe. Gamma-ray bursts are fleeting yet cataclysmic explosions, releasing more energy in a few seconds than our Sun will emit over its entire lifetime. The remnant we're exploring today is a ghostly echo of such an event, a testament to the sheer force that once tore through this region of the Andromeda Galaxy's halo. This particular remnant was detected through a combination of space-based observatories and ground-based telescopes, which captured the faint afterglow of the burst long after the initial explosion had faded. Gamma-ray bursts are notoriously difficult to study because they occur without warning and vanish almost as quickly as they appear. However, the afterglow lasting hours, days, or even weeks provides a crucial window into understanding these cosmic fireworks. By analyzing the light and radiation emitted by the remnant, astronomers can piece together the story of what happened here billions of years ago. The energy released during a gamma-ray burst is staggering. In just a fraction of a second, these bursts can outshine entire galaxies, emitting radiation across the electromagnetic spectrum. The remnant we're examining is thought to be the result of a massive star collapsing into a black hole, a process that triggers a jet of particles moving at nearly the speed of light. When these jets collide with surrounding gas and dust, they produce the intense gamma-ray emissions that define these events. The remnant itself is a diffuse cloud of high-energy particles and radiation, slowly dissipating into the halo over millennia. What makes this remnant particularly intriguing is its role in helping us understand the life cycles of massive stars and the formation of black holes. Gamma-ray bursts are often linked to the deaths of stars many times more massive than our Sun, and studying their remnants provides clues about the conditions that lead to such violent ends. Additionally, these bursts are thought to play a role in the distribution of heavy elements throughout the universe, as the explosions scatter elements like gold and platinum across vast distances. This remnant, therefore, is not just a relic of destruction, it's also a key to understanding how the building blocks of planets and life itself are spread through the cosmos. The implications of studying gamma-ray bursts extend beyond stellar evolution. These events are so powerful that they can be detected across billions of light years, making them valuable tools for probing the early universe. By observing the remnants of gamma-ray bursts in the Andromeda Galaxy's halo, astronomers can gain insights into the conditions of the universe shortly after the Big Bang. The light from these bursts carries information about the gas and dust it has traveled through, offering a unique way to map the structure of the cosmos on the largest scales. As we reflect on this gamma-ray burst remnant, we're reminded of the dual nature of the universe, both destructive and creative. These explosions, while devastating, are also engines of change, shaping the galaxies and the elements that make up everything we see around us. Next, we'll turn our attention to another mysterious object in the halo, a galaxy that seems to defy the very laws of physics, composed almost entirely of dark matter. Stay with us as we continue to unravel the secrets of the Andromeda Galaxy's halo. Now, let's venture into the shadowy depths of the Andromeda Galaxy's halo to uncover one of its most enigmatic residents, a galaxy that seems to exist in the realm of the invisible. This is no ordinary galaxy. It's a dark galaxy, a cosmic structure composed almost entirely of dark matter. Unlike typical galaxies, which are filled with stars, gas, and dust, this one is eerily empty, with only a faint trace of visible matter to hint at its presence. Its discovery has opened a new window into understanding the mysterious substance that makes up most of the universe's mass. The dark galaxy was first detected not by the light it emits, but by the gravitational influence it exerts on its surroundings. Astronomers noticed that stars and gas clouds in the halo were behaving strangely, as if being tugged by an unseen force. By mapping these gravitational distortions, they deduced the presence of a massive object, one that didn't correspond to any visible structure. Further observations using advanced telescopes and gravitational lensing techniques confirmed the existence of this ghostly galaxy, revealing its immense mass despite its lack of visible stars. What makes this discovery so groundbreaking is what it tells us about dark matter. Dark matter is a mysterious substance that doesn't interact with light, making it invisible to traditional telescopes. Yet, it makes up about 85% of the universe's total mass. The dark galaxy in the Andromeda halo is a near-perfect example of a structure dominated by this elusive material. Its existence supports the idea that dark matter can clump together to form galaxies, even without the presence of stars or gas. This challenges our understanding of how galaxies form and evolve, suggesting that dark matter plays a far more significant role than previously thought. The detection of this dark galaxy also provides a unique opportunity to study dark matter in isolation. Most galaxies we observe are a mix of dark matter and visible matter, making it difficult to isolate the properties of dark matter itself. But here, in this nearly starless galaxy, we have a rare chance to observe dark matter's behavior without the interference of stars or gas. By studying its gravitational effects on nearby objects, astronomers hope to uncover clues about the nature of dark matter, whether it's made of particles, how it interacts with gravity, and why it remains so elusive. This discovery also raises intriguing questions about the universe's structure. If dark galaxies are more common than we realize, they could be scattered throughout the cosmos, hidden in plain sight. Their presence would reshape our understanding of the cosmic web, the vast network of matter that connects galaxies across the universe. The dark galaxy in the Andromeda halo might just be the tip of the iceberg, hinting at a hidden population of dark structures waiting to be discovered. As we ponder the implications of this dark galaxy, we're reminded of how much of the universe remains unseen and unknown. It's a humbling reminder that the cosmos is full of mysteries waiting to be unraveled. Next, we'll turn our attention to another strange object in the halo, a vast void where matter seems to have vanished entirely. Stay with us as we continue to explore the wonders of the Andromeda Galaxy's halo. Now, let's shift our gaze to one of the most perplexing features in the Andromeda Galaxy's halo, a vast, empty region known as the cosmic void. Unlike the dense clusters of stars and gas we've explored so far, this void is a staggering expanse of near nothingness stretching across an unimaginable distance. Measuring hundreds of thousands of light-years across, this void is so immense that it challenges our understanding of how matter is distributed in the universe. The discovery of this cosmic void came as a surprise to astronomers. While mapping the halo's structure, they noticed a peculiar gap, a region where the density of stars and gas dropped dramatically, almost to the point of vanishing. At first, they thought it might be an error in their observations, but repeated studies confirmed its existence. This void wasn't just a small pocket of emptiness. It was a colossal, nearly empty space that seemed to defy the typical distribution of matter in the cosmos. So, how does such a void form? One theory suggests that it could be the result of gravitational interactions over billions of years. As galaxies and clusters of matter move and collide, they can push material away, leaving behind vast, empty regions. Another possibility is that the void is a remnant of the early universe, a relic from a time when matter was distributed unevenly, creating pockets of density and emptiness that persist to this day. Whatever its origins, the cosmic void in the Andromeda halo is a striking example of the universe's complexity. The implications of this discovery are profound. Voids like this one play a crucial role in shaping the large-scale structure of the universe. They act as counterpoints to the dense filaments and clusters of the cosmic web, creating a balance that defines the universe's architecture. By studying this void, astronomers can gain insights into how matter is distributed on the grandest scales, and how the universe evolved from its early, chaotic state to the structured cosmos we see today. This cosmic void also raises intriguing questions about the nature of space itself. Is it truly empty, or does it contain hidden forms of matter or energy that we can't yet detect? Some scientists speculate that voids might harbor traces of dark energy, the mysterious force driving the universe's accelerated expansion. If so, studying voids could provide clues to one of the greatest mysteries in modern cosmology. As we contemplate the vast emptiness of this cosmic void, we're reminded of the universe's duality, its ability to be both densely packed with matter and eerily empty at the same time. It's a humbling reminder of how much we still have to learn about the cosmos. Next, we'll turn our attention to another fascinating object in the halo, a pair of black holes locked in a gravitational dance. Stay with us as we continue to uncover the secrets of the Andromeda Galaxy's halo. Now, let's venture into the heart of the Andromeda Galaxy's halo to uncover one of the most dynamic and mysterious objects yet, a pair of black holes locked in a gravitational dance. Known as a binary black hole system, this duo is a cosmic spectacle, with each black hole orbiting the other in a relentless spiral that sends ripples through the fabric of space-time. The masses of these black holes are staggering. One is estimated to be around 20 million times the mass of our Sun, while its companion weighs in at roughly 15 million solar masses. Together, they form a system so massive that their gravitational pull warps the surrounding space, creating a region of intense energy and distortion. But how were these titans detected? The answer lies in the subtle yet powerful signals they emit: gravitational waves. Gravitational waves are ripples in space-time caused by the acceleration of massive objects, and binary black holes are among the most prolific sources of these waves. As the two black holes orbit each other, they lose energy in the form of gravitational waves, causing their orbits to gradually shrink. This process, known as in-spiral, eventually leads to a dramatic collision and merger. The detection of these waves was made possible by advanced observatories like LIGO and Virgo, which can sense the faint distortions in space-time caused by such events. The discovery of this binary black hole system in the Andromeda halo was a milestone in astrophysics. It not only confirmed the existence of such pairs, but also provided a unique opportunity to study the behavior of black holes in close proximity. The gravitational waves they produce carry valuable information about their masses, spins, and the dynamics of their orbits, offering a window into the extreme physics governing these enigmatic objects. But what makes this binary system particularly fascinating is its potential to reveal the origins of black hole pairs. One theory suggests that they formed from two massive stars that collapsed into black holes and remained gravitationally bound. Another possibility is that they were brought together by the dense environment of the galactic halo, where interactions between black holes are more likely. Regardless of their origins, this binary system is a testament to the violent and chaotic processes that shape the universe. As we observe these black holes spiraling toward their inevitable collision, we're reminded of the immense forces at play in the cosmos. Their gravitational waves not only provide a new way to study the universe, but also hint at the countless other binary systems that may be lurking in the depths of space. Next, we'll explore another intriguing object in the halo, a comet from another star system, hurtling through the vast expanse of the Andromeda Galaxy. Stay tuned as we continue our journey through the mysteries of the halo. Shifting our gaze from the gravitational dance of black holes, we now turn to a visitor from beyond the stars, a comet unlike any other in the Andromeda halo. This interstellar comet, a rare and fleeting traveler, has journeyed across the vast expanse of space, originating from a star system far removed from our own. Its presence in the halo offers a unique opportunity to study the building blocks of other star systems and the secrets they carry. Unlike comets in our solar system, which are born from the remnants of its formation, this interstellar comet comes from an entirely different cosmic neighborhood. Its trajectory is a straight line, unbound by the gravitational pull of any single star, a clear sign that it is a wanderer passing through rather than a permanent resident. This path suggests it was ejected from its home system, perhaps by a close encounter with a massive planet or the gravitational tug of a passing star. The composition of this comet is equally fascinating. Early observations reveal that it contains a mix of ices, dust, and organic compounds, much like comets in our solar system. However, subtle differences in its chemical makeup hint at the unique conditions of its birthplace. For instance, the ratios of certain isotopes in its ices differ from those found in solar system comets, providing clues about the environment in which it formed. These differences are like cosmic fingerprints telling the story of its origins and the journey it has undertaken. What truly sets this comet apart is its speed. Traveling at tens of thousands of kilometers per hour, it moves far faster than comets bound to our Sun. This incredible velocity is a testament to the forces that propelled it into interstellar space, allowing it to traverse the immense distances between stars. As it streaks through the Andromeda halo, it leaves behind a faint trail of gas and dust, a temporary signature of its passage. The discovery of this interstellar comet is a reminder of the interconnectedness of the cosmos. While it may be a transient visitor, its presence enriches our understanding of the diversity of celestial objects and the processes that shape them. By studying its composition and trajectory, astronomers can piece together the story of its origins and the conditions that govern other star systems. As we continue our exploration of the Andromeda halo, this interstellar comet serves as a bridge between our galaxy and the wider universe, offering a glimpse into the vast and varied tapestry of cosmic phenomena. Next, we'll delve into another enigmatic object, a bubble of hot gas expanding through the halo, reshaping the very fabric of this galactic region. Stay with us as we uncover more of the halo's hidden wonders. Now, let's turn our attention to a phenomenon that seems almost alive, a cosmic bubble of hot gas, expanding and reshaping its surroundings in the Andromeda halo. This immense structure, stretching across hundreds of light years, is a dynamic force within the galaxy's outer reaches, offering a glimpse into the energetic processes that shape galactic environments. The origins of this cosmic bubble are tied to some of the most powerful events in the universe. It likely formed from the shockwaves of supernova explosions or the intense winds generated by massive stars. These events release vast amounts of energy, heating the surrounding gas and pushing it outward, creating a bubble-like structure. Over time, this bubble expands, carving out a space within the halo and influencing the material around it. The size of this bubble is staggering. Imagine a sphere so large that it could encompass entire star systems, its edges marked by a thin shell of compressed gas and dust. This shell acts as a boundary, separating the hot, turbulent interior from the cooler, more diffuse material of the halo. As the bubble expands, it sweeps up surrounding gas, triggering waves of star formation along its edges and leaving behind a trail of newly ignited stars. What makes this bubble particularly fascinating is how it interacts with its environment. The hot gas inside the bubble exerts pressure on the surrounding material, creating ripples and distortions in the halo's structure. These interactions can lead to the formation of new structures, such as filaments of gas or pockets of increased density, which may eventually collapse to form stars or even entire star clusters. In this way, the bubble is not just a passive object but an active participant in the evolution of the halo. The cosmic bubble also serves as a laboratory for studying the physics of hot gas and its behavior in extreme conditions. By observing the temperature, density, and movement of the gas within the bubble, astronomers can gain insights into the processes that drive its expansion and the forces that shape galactic halos. These observations help us understand how energy is transferred and distributed throughout the universe, influencing the formation and evolution of galaxies. As we continue to explore the Andromeda halo, this cosmic bubble stands as a testament to the dynamic and ever-changing nature of the cosmos. Its presence reminds us that even in the seemingly quiet outer reaches of a galaxy, powerful forces are at work, shaping the universe in ways we are only beginning to comprehend. Next, we'll uncover another mysterious object, a quasar from the early universe, shining brightly across billions of years. Stay with us as we journey deeper into the halo's secrets. Now, let's journey back in time to one of the most luminous objects in the universe, an ancient quasar shining brightly from the early cosmos. This quasar, located in the Andromeda halo, is a beacon from a time when the universe was young, offering us a rare glimpse into the conditions that shaped the infancy of galaxies. Quasars are among the most energetic objects in the universe, powered by supermassive black holes at the centers of galaxies. As these black holes consume vast amounts of gas and dust, they release incredible amounts of energy, outshining entire galaxies. This particular quasar, however, is special because of its age. It dates back to a time when the universe was only a fraction of its current age, making it a relic from the cosmic dawn. The brightness of this quasar is staggering. Even from billions of light-years away, its light pierces through the darkness of space, allowing us to observe it across unimaginable distances. This brightness is not just a testament to the quasar's power, but also a tool for astronomers. By studying its light, we can learn about the composition of the early universe, the density of matter, and even the formation of the first galaxies. What makes this ancient quasar particularly fascinating is what it reveals about the early cosmos. During this period, the universe was much denser and hotter, filled with swirling clouds of gas that would eventually collapse to form stars and galaxies. The quasar's light has traveled through these ancient clouds, picking up clues about their composition and structure. By analyzing this light, astronomers can piece together a picture of the universe as it was billions of years ago. This quasar also provides insights into the growth of supermassive black holes. Its existence so early in the universe challenges our understanding of how these colossal objects form and evolve. Did they grow rapidly from massive seeds, or did they form through the merging of smaller black holes? The answers lie in the light of this ancient quasar, waiting to be deciphered. As we study this quasar, we are not just looking at a distant object but peering into the past. Its light carries the story of a young universe, one that was chaotic, energetic, and full of potential. By unraveling its secrets, we gain a deeper understanding of how the cosmos evolved into the universe we see today. Next, we'll explore a region where the very fabric of space seems to bend, a dark energy hotspot that defies our understanding of the universe's expansion. Stay with us as we continue our journey through the Andromeda halo. Now, shifting our gaze to one of the most perplexing phenomena in the Andromeda halo, we encounter a region that seems to defy the very laws of the universe, a dark energy hotspot. This mysterious area, where dark energy appears to be unusually concentrated, challenges our understanding of how the cosmos expands and evolves. Dark energy, the enigmatic force driving the accelerated expansion of the universe, is typically thought to be evenly distributed. But here, in this peculiar region, it seems to cluster in ways that leave scientists both intrigued and baffled. The discovery of this dark energy hotspot came as a surprise during observations of the Andromeda halo. Astronomers noticed subtle distortions in the light from distant galaxies, a telltale sign of gravitational lensing. However, these distortions didn't align with the expected distribution of matter. Instead, they pointed to an invisible force, dark energy, acting in ways that no one had anticipated. This anomaly sparked a wave of research as scientists scrambled to understand what could cause such a concentration of dark energy in this specific region. One leading theory suggests that this hotspot might be the result of a cosmic collision or interaction between galaxies. When galaxies merge or pass close to one another, their gravitational fields can create ripples in the fabric of space-time. These ripples might, in turn, amplify or concentrate dark energy in localized areas. Another possibility is that this region could be a remnant of the early universe, a pocket where dark energy behaved differently during the cosmos's formative years. Whatever the cause, this hotspot offers a rare opportunity to study dark energy in a concentrated form, something that could revolutionize our understanding of this elusive force. The implications of this discovery are profound. Dark energy makes up about 68% of the universe's total energy content, yet we know almost nothing about its true nature. By studying this hotspot, scientists hope to uncover clues about how dark energy interacts with matter and space-time. Does it vary across the universe, or is this concentration a rare exception? Could it hint at new physics beyond our current models? These are the questions that keep astronomers up at night, and this dark energy hotspot might hold the answers. As we continue to explore this enigmatic region, we are reminded of how much we still have to learn about the universe. Dark energy, though invisible, shapes the fate of the cosmos, and this hotspot in the Andromeda halo is a window into its mysteries. Next, we'll turn our attention to another extraordinary phenomenon, a cosmic jet streaming from a black hole, a spectacle of power and precision that defies imagination. Stay with us as we delve deeper into the wonders of the Andromeda halo. Now, let's journey into the heart of one of the most awe-inspiring phenomena in the Andromeda halo, a cosmic jet, a torrent of particles blasting out from a supermassive black hole at nearly the speed of light. These jets are among the most energetic events in the universe, and the one in Andromeda's halo is no exception. Stretching across thousands of light years, this jet is a testament to the raw power of black holes and their ability to shape their surroundings in dramatic ways. The discovery of this cosmic jet came through a combination of radio and X-ray observations. Astronomers noticed a bright, narrow beam of radiation extending far beyond the black hole itself. This beam, composed of highly energized particles, was moving at incredible speeds close to the speed of light. The jet's immense energy is generated by the black hole's intense gravitational pull, which heats up surrounding matter and accelerates it into space. What makes this jet particularly fascinating is its precision. Despite its chaotic origins, it travels in a remarkably straight line, carving a path through the halo. The impact of this jet on the Andromeda halo is profound. As it travels, it interacts with the surrounding gas and dust, heating it up and pushing it aside. This process can trigger the formation of new stars in some regions while disrupting existing structures in others. The jet also acts as a cosmic particle accelerator, sending high-energy particles far into the halo, where they can influence the behavior of other celestial objects. In a way, this jet is like a sculptor, reshaping the halo's landscape with its immense energy. But what truly sets this cosmic jet apart is its role in helping us understand black holes and their environments. By studying its properties, scientists can learn more about how black holes consume matter and release energy. The jet's speed, structure, and interactions with the halo provide valuable clues about the physics of these enigmatic objects. It's a reminder that even in the vastness of space, the smallest details can reveal the grandest truths. As we marvel at this cosmic jet, we're reminded of the dynamic and ever-changing nature of the universe. Next, we'll explore a region filled with the remnants of stars that have reached the end of their lives, a stellar graveyard that holds secrets about the life cycles of stars. Stay with us as we uncover more mysteries in the Andromeda halo. Now, let's turn our attention to a quieter, yet equally fascinating corner of the Andromeda halo, a stellar graveyard, a region where stars have reached the end of their lives and left behind their remnants. This eerie expanse is filled with the remains of countless stars, each telling a story of cosmic birth, life, and eventual death. Unlike the vibrant, energetic phenomena we've explored so far, this graveyard offers a glimpse into the final chapters of stellar evolution. The stellar graveyard is composed primarily of white dwarfs, neutron stars, and black holes, objects that represent the end stages of stars of different sizes. White dwarfs, the remnants of stars like our Sun, are dense, Earth-sized cores that glow faintly as they cool over billions of years. Neutron stars, the collapsed cores of more massive stars, are incredibly dense, packing the mass of a star into a sphere just a few miles across. And then there are black holes, the ultimate fate of the most massive stars, where gravity is so strong that not even light can escape. Together, these remnants form a haunting yet beautiful tapestry of stellar afterlife. This graveyard didn't form overnight. It's the result of billions of years of stellar evolution. When stars exhaust their nuclear fuel, they shed their outer layers in spectacular explosions or gentle puffs, leaving behind their dense cores. Over time, these remnants accumulate in the halo, creating a region rich in cosmic history. The process is a natural part of the life cycle of stars, but it's one that unfolds over timescales far beyond human comprehension. What makes this stellar graveyard particularly intriguing is what it reveals about the life cycles of stars. By studying the distribution and properties of these remnants, astronomers can piece together the history of star formation in the Andromeda halo. For instance, the abundance of white dwarfs suggests that many stars in this region were similar in size to our Sun, while the presence of neutron stars and black holes points to a population of more massive stars that lived fast and died young. This graveyard is like a cosmic archive preserving the stories of stars that once shone brightly. But the graveyard isn't just a place of endings, it's also a site of potential new beginnings. The material ejected by dying stars enriches the surrounding space with heavy elements, which can eventually form new stars and planets. In a way, the graveyard is a reminder that even in death, stars contribute to the ongoing cycle of creation in the universe. As we reflect on this quiet yet profound region, we're reminded of the interconnectedness of all cosmic phenomena. Next, we'll venture into a rare and mysterious sight, a star that exists not within a galaxy, but in the vast emptiness between them. Stay with us as we uncover the secrets of this intergalactic wanderer. Now, let's journey beyond the boundaries of galaxies to uncover one of the most elusive objects in the cosmos, an intergalactic star. Unlike the stars we're familiar with, which are bound within galaxies, this solitary wanderer drifts freely in the vast emptiness between them. It's a rare and mysterious phenomenon that challenges our understanding of how stars form and where they can exist. The origins of this intergalactic star are as fascinating as they are puzzling. One leading theory suggests that it was once part of a galaxy, but was violently ejected during a close encounter or collision with another galaxy. Imagine two galaxies passing near each other, their gravitational forces pulling and twisting stars out of their orbits. In the chaos, some stars are flung into the void, destined to drift alone through the intergalactic medium. Another possibility is that this star formed in isolation, perhaps from a small cloud of gas that somehow escaped the gravitational pull of any galaxy. Either way, its existence is a testament to the dynamic and often unpredictable nature of the universe. Discovering such a star is no small feat. Astronomers first detected it through its faint light, which stood out against the darkness of intergalactic space. Unlike stars within galaxies, which are often obscured by dust and gas, this lone star shines clearly, offering a rare opportunity to study its properties. Advanced telescopes and imaging techniques were crucial in pinpointing its location and confirming its status as an intergalactic wanderer. Its discovery was a moment of both excitement and curiosity, as it opened up new questions about the distribution of stars in the universe. What makes this star so rare is not just its location, but also the conditions required for its existence. Stars typically form within dense clouds of gas and dust found in galaxies, where gravity can pull material together to ignite nuclear fusion. For a star to form or survive in the sparse environment between galaxies is extraordinary. The intergalactic medium is incredibly thin, with densities millions of times lower than those found within galaxies. This star's ability to shine in such a desolate region is a reminder of the universe's capacity for surprises. Studying this intergalactic star provides valuable insights into the processes that shape the cosmos. It challenges our assumptions about where stars can exist and how they can form. By analyzing its light, astronomers can learn about its composition, age, and even its trajectory through space. Each piece of data adds to our understanding of the broader cosmic landscape and the forces that govern it. As we marvel at this lone star, we're reminded of the vastness and complexity of the universe. It's a place where even the most isolated objects have stories to tell. Next, we'll turn our attention to a cosmic lighthouse, a pulsar with an unusually regular signal that has captivated astronomers for decades. Stay with us as we explore this beacon of the cosmos. Now, let's shift our gaze to a celestial beacon that has fascinated astronomers for decades, the cosmic lighthouse, a pulsar with an unusually regular signal. Pulsars are the remnants of massive stars that have exploded in supernova, leaving behind incredibly dense, rapidly spinning cores. What makes this particular pulsar stand out is the precision of its pulses, which are so consistent that they rival the accuracy of atomic clocks here on Earth. The discovery of this pulsar was a milestone in astrophysics. Astronomers first detected its rhythmic signals using radio telescopes, which picked up the faint but unmistakable bursts of energy emitted as the pulsar spins. These pulses occur at such regular intervals that they can be predicted down to the millisecond. This level of precision is rare even among pulsars, making this object a true cosmic marvel. So, how does a pulsar produce such a steady signal? As the pulsar spins, it emits beams of radiation from its magnetic poles. If these beams happen to point toward Earth as the pulsar rotates, we detect them as pulses of light or radio waves. The faster the pulsar spins, the more frequent the pulses. This particular pulsar spins at an incredibly stable rate, creating a signal so reliable that it has been proposed as a potential tool for interstellar navigation. Imagine spacecraft using pulsars as cosmic GPS markers, triangulating their position in the vastness of space by measuring the timing of these pulses. The importance of this pulsar extends beyond navigation. Its regularity provides a unique opportunity to study the physics of extreme environments. Pulsars are surrounded by incredibly strong magnetic fields and gravitational forces, conditions that are impossible to replicate on Earth. By observing this pulsar, scientists can test theories about the behavior of matter under such extreme conditions, offering insights into the fundamental laws of physics. Moreover, this pulsar's signal has been used to detect subtle changes in the fabric of spacetime itself. When gravitational waves pass through the region, they cause tiny distortions in the timing of the pulses. These distortions, though minuscule, can be measured, providing a new way to study these ripples in spacetime and the cosmic events that produce them. As we marvel at this cosmic lighthouse, we're reminded of the precision and order that exist even in the most extreme corners of the universe. Its steady pulses are not just a curiosity but a tool for exploration and discovery. Next, we'll delve into the remnants of an ancient galaxy, a galactic fossil that holds clues to the early universe. Stay with us as we uncover more mysteries of the Andromeda Galaxy's halo. Now, let's journey back in time to uncover one of the most ancient relics in the Andromeda Galaxy's halo, a galactic fossil, a remnant of an ancient galaxy that predates even Andromeda itself. This celestial artifact is a window into the early universe, offering clues about how galaxies formed and evolved over billions of years. This galactic fossil is composed of some of the oldest stars ever observed, with ages estimated to be over 13 billion years. To put that into perspective, these stars were born when the universe was still in its infancy, just a few 100 million years after the Big Bang. Their composition is strikingly different from younger stars, containing far fewer heavy elements like iron and carbon. This scarcity of metals tells us that these stars formed from the primordial gas that filled the early universe before generations of supernova enriched the cosmos with heavier elements. The discovery of this ancient remnant was no small feat. Astronomers identified it by analyzing the motion and chemical makeup of stars in the halo, pinpointing a group that stood out due to their unique properties. These stars move in a distinct pattern, suggesting they were once part of a smaller galaxy that was absorbed by Andromeda billions of years ago. This process, known as galactic cannibalism, is a key way larger galaxies like Andromeda grow over time. What makes this galactic fossil so significant is what it reveals about the early universe. By studying its stars, scientists can piece together the conditions that existed when the first galaxies were forming. The lack of heavy elements in these stars supports the theory that the early universe was dominated by hydrogen and helium, with heavier elements only emerging later through the life cycles of stars. Additionally, the structure of this fossil provides insights into the chaotic environment of the early cosmos. The stars are arranged in a loose, irregular cluster, unlike the tightly bound globular clusters we see today. This suggests that early galaxies were smaller, more chaotic, and less organized than their modern counterparts. As we examine this galactic fossil, we're reminded of the dynamic and ever-changing nature of the universe. It's a testament to the fact that even the largest structures in the cosmos have humble beginnings. Next, we'll turn our attention to a massive storm of charged particles, a cosmic tempest that rages through the halo. Stay with us as we continue to unravel the mysteries of the Andromeda Galaxy's halo. Now, let's shift our gaze to a phenomenon that embodies the raw power and chaos of the cosmos, a cosmic storm, a tempest of charged particles swirling through the Andromeda Galaxy's halo. This isn't just any storm, it's a colossal maelstrom of energy, stretching across vast distances and unleashing forces that defy imagination. This cosmic storm is fueled by charged particles, primarily electrons and protons, accelerated to incredible speeds by magnetic fields and shock waves within the halo. The energy involved is staggering, equivalent to millions of supernovae exploding simultaneously. These particles spiral along magnetic field lines, creating intense radiation that can be detected across multiple wavelengths, from radio waves to X-rays. Detecting such a storm was no simple task. Astronomers first noticed unusual patterns in the halo's radio emissions, which hinted at the presence of high-energy particles. Further observations using X-ray telescopes revealed the full extent of this phenomenon, showing a vast, turbulent region where particles collide and release bursts of energy. The storm's sheer scale is breathtaking, spanning tens of thousands of light years and dwarfing even the largest storms in our own galaxy. The effects of this cosmic storm on the halo are profound. The charged particles interact with the surrounding gas, heating it to extreme temperatures and preventing it from cooling and forming new stars. This creates a feedback loop where the storm's energy sustains its own turbulence, making it a long-lasting feature of the halo. Additionally, the storm's magnetic fields can influence the motion of other objects in the halo, bending the paths of cosmic rays and even shaping the distribution of gas and dust. What makes this storm particularly fascinating is its role in the larger ecosystem of the halo. It acts as a cosmic mixer, redistributing energy and matter across vast distances. This process can trigger new waves of star formation in some regions while quenching it in others, creating a dynamic and ever-changing environment. As we marvel at this cosmic tempest, we're reminded of the incredible forces at work in the universe. It's a vivid illustration of how even the most chaotic phenomena can shape the evolution of galaxies. Next, we'll explore a mysterious cluster of stars that defy our expectations, a dark star cluster where light seems to vanish. Stay with us as we continue to uncover the secrets of the Andromeda Galaxy's halo. Now, let's turn our attention to a celestial enigma that defies the very nature of what we expect from stars, a dark star cluster. Unlike the glittering star clusters we're familiar with, this mysterious group of stars emits almost no light, making it one of the most puzzling objects in the Andromeda Galaxy's halo. The discovery of this dark star cluster came as a surprise to astronomers. While studying the halo's faint glow, they noticed a region where the expected light from stars was conspicuously absent. Instead, gravitational measurements revealed the presence of a dense cluster of objects exerting a strong pull on their surroundings. This invisible cluster, composed of stars that emit almost no visible light, challenges our understanding of how star clusters form and evolve. So, what makes these stars so dark? The answer lies in their composition. Unlike typical stars, which shine brightly due to nuclear fusion in their cores, the stars in this cluster are either extremely old and dim or belong to a rare class of stellar remnants. Some may be white dwarfs, neutron stars, or even black holes, objects that have exhausted their fuel and no longer emit significant light. Others could be brown dwarfs, failed stars that never ignited fusion in the first place. Together, they form a shadowy congregation that remains hidden from traditional optical telescopes. The existence of this dark star cluster raises intriguing questions about the halo's history. How did such a cluster form in the first place? One theory suggests it could be the remnant of a dwarf galaxy that was torn apart by Andromeda's gravity, leaving behind its densest core of stars. Another possibility is that it formed in isolation, a rare and ancient relic from the early universe. Whatever its origins, this cluster forces us to rethink our assumptions about star formation and the diversity of stellar populations in galactic halos. What's even more fascinating is how this cluster interacts with its environment. Despite its lack of light, its gravitational influence is profound. It can warp the paths of nearby stars and gas, acting as a hidden anchor in the halo's structure. This invisible presence reminds us that much of the universe's activity occurs beyond what we can see, hidden in the shadows of the cosmos. As we ponder the mysteries of this dark star cluster, we're reminded of how much remains to be discovered in the Andromeda Galaxy's halo. Next, we'll journey to a bridge of gas connecting two galaxies, a cosmic thread that binds the universe together. Stay with us as we continue to unravel the secrets of this extraordinary region. Now, let's shift our gaze to a cosmic marvel that stitches the fabric of the universe together, an intergalactic bridge. This extraordinary structure, a vast stream of gas, stretches across the void, connecting two galaxies in the Andromeda Galaxy's halo. It's a celestial thread that binds these massive systems, offering a glimpse into the intricate dance of galactic interactions. The origins of this intergalactic bridge are as fascinating as its appearance. Astronomers believe it formed through a process known as tidal stripping, where the gravitational pull of one galaxy tears gas and dust from another during a close encounter. Over millions of years, this material is stretched into a long, flowing bridge, creating a luminous pathway between the two galaxies. This process not only shapes the bridge, but also leaves a lasting imprint on the galaxies involved, altering their structure and evolution. Detecting such a bridge is no small feat. Unlike stars or planets, gas clouds emit faint signals that are easily overshadowed by brighter objects. To uncover this hidden structure, astronomers relied on advanced radio telescopes and spectroscopy, which allowed them to map the distribution and movement of gas in the halo. By analyzing the subtle shifts in light and radio waves, they pieced together the bridge's shape and composition, revealing its role in the cosmic ballet of galactic interactions. The significance of this intergalactic bridge extends far beyond its striking appearance. It serves as a vital conduit for the exchange of material between galaxies, fueling star formation and influencing their growth. As gas flows across the bridge, it can trigger bursts of new stars in the galaxies it connects, shaping their futures in profound ways. This process highlights the interconnectedness of the universe, where even the most distant objects are linked by invisible threads of matter and energy. Moreover, the bridge offers a unique opportunity to study the dynamics of galactic collisions and mergers. By observing how gas moves and interacts within the bridge, scientists can gain insights into the forces that drive these cosmic events. It's a living laboratory, providing clues about how galaxies evolve and how structures like the Andromeda Galaxy's halo came to be. As we marvel at this intergalactic bridge, we're reminded of the delicate balance that governs the cosmos. It's a testament to the unseen forces that shape the universe, connecting galaxies across vast distances and weaving them into a single, intricate tapestry. Next, we'll explore a star with a diamond core, a glittering gem hidden in the depths of space. Stay with us as we continue our journey through the wonders of the Andromeda Galaxy's halo. Now, let's turn our attention to a celestial gem that sparkles in the depths of space, a star with a diamond core. This extraordinary object, known as the cosmic diamond, is one of the rarest and most fascinating discoveries in the Andromeda Galaxy's halo. Imagine a star so dense and ancient that its core has crystallized into a diamond, creating a glittering treasure hidden within the vast expanse of the cosmos. The formation of this cosmic diamond begins with the life cycle of a star. When a star similar to our Sun exhausts its nuclear fuel, it sheds its outer layers, leaving behind a dense remnant called a white dwarf. Over billions of years, the intense pressure and cooling temperatures within the white dwarf cause its carbon-rich core to crystallize, forming a diamond-like structure. This process is incredibly slow, taking trillions of years to complete, which is why such stars are exceedingly rare. Discovering a star with a diamond core is no easy task. These objects are faint and often obscured by the glare of brighter stars. Astronomers identified this particular star by analyzing its light spectrum, which revealed the unique signatures of crystallized carbon. Advanced telescopes and sensitive instruments were crucial in detecting these subtle clues, allowing scientists to confirm the presence of a diamond core. What makes this cosmic diamond so remarkable is not just its rarity, but also what it tells us about the universe. It serves as a time capsule, preserving the conditions of an ancient star that existed long before the Andromeda Galaxy took its current form. By studying this star, scientists can gain insights into the processes that govern the evolution of stellar remnants and the ultimate fate of stars like our Sun. The cosmic diamond also challenges our understanding of stellar physics. Its existence raises questions about how such extreme conditions can lead to the formation of crystalline structures within a star. This discovery opens new avenues for research, offering a glimpse into the exotic states of matter that exist in the universe. As we marvel at this glittering star, we're reminded of the incredible diversity and beauty of the cosmos. It's a testament to the wonders that await us in the depths of space, where even the most ordinary objects can transform into something extraordinary. Next, we'll explore a galactic fountain, a breathtaking flow of gas that shapes the Andromeda Galaxy's halo. Stay with us as we continue our journey through these cosmic mysteries. Now, let's shift our gaze to a breathtaking phenomenon that defies the stillness of space, a galactic fountain. This spectacular flow of gas cascading out of the Andromeda Galaxy is one of the most dynamic and visually stunning features in its halo. Picture a colossal fountain, not of water but of ionized gas, arcing high above the galactic plane and raining back down in a cosmic cycle of creation and destruction. The energy driving this galactic fountain comes from the heart of the galaxy itself. Supermassive black holes, star formation, and supernova explosions all contribute to the immense forces that propel gas outward. These events generate powerful winds and shockwaves, pushing gas into the halo at incredible speeds. Over time, this gas cools and condenses, eventually falling back into the galaxy, where it can fuel new generations of stars. Detecting such a fountain required cutting-edge technology and precise observations. Astronomers used radio telescopes to map the movement of gas, revealing the intricate flow patterns. By analyzing the light emitted by the gas, they could trace its temperature, density, and velocity, piecing together the structure of this vast fountain. The data showed that the gas travels thousands of light years before returning to the galaxy, creating a continuous cycle of outflow and inflow. The impact of this galactic fountain on the Andromeda Galaxy's halo is profound. It redistributes gas and metals, enriching the halo with elements forged in the hearts of stars. This process plays a crucial role in regulating star formation, as the returning gas provides the raw material needed to create new stars. At the same time, the outflowing gas carries energy and momentum into the halo, shaping its structure and influencing its evolution. What makes this fountain so fascinating is its role in the life cycle of galaxies. It's a reminder that galaxies are not static entities but dynamic systems, constantly evolving through processes like these. The galactic fountain also offers a glimpse into the interconnectedness of cosmic phenomena, where the actions of stars, black holes, and gas flows are all part of a larger, intricate dance. As we marvel at this cosmic cascade, we're reminded of the beauty and complexity of the universe. It's a testament to the forces that shape galaxies and the delicate balance that sustains them. Next, we'll explore a cosmic mirror, a region that reflects light in unusual ways, offering a new perspective on the Andromeda Galaxy's halo. Stay with us as we continue our journey through these celestial wonders. Now, let's turn our attention to a phenomenon that bends the rules of light itself, the cosmic mirror. Nestled within the Andromeda Galaxy's halo, this extraordinary region acts like a celestial looking glass, reflecting light in ways that challenge our understanding of optics and space. Imagine a vast, invisible surface that doesn't just bounce light back but twists and distorts it, creating a kaleidoscope of cosmic reflections. The discovery of this cosmic mirror came as a surprise to astronomers. While studying the halo, they noticed an unusual pattern of light that didn't match any known celestial objects. Instead of a single source, the light appeared to be scattered and refocused, as if it had been bounced off an unseen surface. Further observations revealed that this region was acting like a natural mirror, reflecting light from distant stars and galaxies in unexpected directions. So, how does this cosmic mirror work? The key lies in the unique properties of the region. Dense clouds of gas and dust, combined with strong magnetic fields, create a reflective surface that bends and redirects light. Unlike a traditional mirror which reflects light in a straightforward manner, this cosmic mirror distorts the light, creating multiple reflections and magnifying distant objects. This phenomenon, known as gravitational lensing, allows astronomers to study faraway galaxies and stars in greater detail than ever before. The implications of this cosmic mirror are profound. By magnifying and reflecting light from distant objects, it provides a rare opportunity to observe the early universe. Astronomers can use this natural lens to study galaxies that would otherwise be too faint or too far away to detect. It's like having a built-in telescope within the halo, offering a clearer view of the cosmos. But the cosmic mirror isn't just a tool for observation, it's also a window into the physics of light and matter. The way it bends and distorts light reveals information about the distribution of dark matter and the structure of the halo itself. By studying these reflections, scientists can piece together the complex interplay of forces that shape the Andromeda Galaxy and its surroundings. What makes this cosmic mirror so captivating is its ability to transform our perspective. It reminds us that the universe is full of surprises, where even something as familiar as light can behave in extraordinary ways. As we continue to explore the Andromeda Galaxy's halo, the cosmic mirror stands as a testament to the ingenuity of nature and the endless possibilities of discovery. Next, we'll delve into the mysterious dark matter halo, a region with an unusually high concentration of dark matter that challenges our understanding of the cosmos. Stay with us as we uncover more secrets hidden within this enigmatic galaxy. Now, let's shift our focus to one of the most enigmatic features of the Andromeda Galaxy's halo, the dark matter halo. This region, with its unusually high concentration of dark matter, has become a focal point for astronomers seeking to unravel the mysteries of this invisible substance that makes up a significant portion of our universe. The discovery of this dark matter halo was not straightforward. Unlike stars or gas clouds, dark matter doesn't emit, absorb, or reflect light, making it invisible to traditional telescopes. Instead, its presence was inferred through its gravitational effects on visible matter. Astronomers noticed that stars and gas clouds in the halo were moving in ways that couldn't be explained by the gravitational pull of visible matter alone. This discrepancy pointed to the existence of something unseen, dark matter. To detect this elusive substance, scientists relied on a technique called gravitational lensing. As light from distant galaxies passes through the halo, it bends around the dense concentrations of dark matter, creating distortions in the light's path. By analyzing these distortions, astronomers were able to map the distribution of dark matter in the halo, revealing a vast, invisible structure that extends far beyond the galaxy's visible components. The significance of this dark matter halo cannot be overstated. It provides crucial insights into the nature of dark matter itself, a substance that makes up about 85% of the universe's total mass. By studying its distribution and interactions, scientists hope to answer fundamental questions about how galaxies form and evolve. The dark matter halo acts as a cosmic scaffold, holding the galaxy together and shaping its structure over billions of years. But the dark matter halo isn't just a passive framework, it's also a dynamic player in the galaxy's evolution. Its gravitational influence affects the motion of stars and gas, driving the formation of new stars and influencing the behavior of black holes. Understanding this interplay between dark matter and visible matter is key to unlocking the secrets of galactic evolution. What makes this dark matter halo so fascinating is its ability to challenge our understanding of the universe. It reminds us that much of what exists is hidden from view, waiting to be discovered through innovative techniques and persistent curiosity. As we continue to explore the Andromeda Galaxy's halo, the dark matter halo stands as a testament to the unseen forces that shape our cosmos. Next, we'll turn our attention to the interstellar dust cloud, a massive cloud of dust that obscures light from distant stars, offering a unique glimpse into the halo's composition. Stay with us as we uncover more of the Andromeda Galaxy's hidden wonders. Now, let's venture into the shadowy depths of the Andromeda Galaxy's halo, where we encounter the interstellar dust cloud, a colossal veil of cosmic dust that obscures the light from distant stars. This massive cloud, composed of tiny particles of silicates, carbon compounds, and ice, acts like a cosmic curtain, dimming the brilliance of stars and galaxies behind it. Its presence not only challenges astronomers but also offers a unique window into the halo's composition and history. The discovery of this interstellar dust cloud came about through observations of the halo's light. Astronomers noticed that certain regions appeared unusually dim, as if something were blocking the light from stars and galaxies beyond. By analyzing the wavelengths of light that managed to pass through, they identified the telltale signatures of dust particles. These particles, though minuscule, collectively form a dense cloud that stretches across vast distances, creating a barrier to visible light. What makes this dust cloud particularly intriguing is its composition. Unlike the dust found within galaxies, which is often heated by stars and glows faintly, the dust in the halo remains cold and dark. This suggests that it has been undisturbed for billions of years, preserving a pristine record of the early universe. By studying its chemical makeup, scientists can piece together the history of star formation and the processes that shaped the halo over eons. The impact of this dust cloud on astronomical observations is significant. It complicates the study of distant objects by absorbing and scattering their light, making it harder to gather clear data. However, this challenge also presents an opportunity. By observing how light interacts with the dust, astronomers can learn more about its properties, such as the size and shape of the particles, as well as their distribution within the cloud. Moreover, this interstellar dust cloud plays a crucial role in the life cycle of the galaxy. Dust particles serve as the building blocks for new stars and planets, and their presence in the halo hints at the potential for star formation in these remote regions. While the halo is often thought of as a quiet, unchanging expanse, the existence of this dust cloud suggests that it may be more dynamic than we once believed. As we peer through this cosmic veil, we're reminded of the complexity and mystery that define the Andromeda Galaxy's halo. The interstellar dust cloud is not just an obstacle to observation, It's a treasure trove of information, waiting to reveal its secrets to those who dare to look closer. Next, we'll explore the cosmic echo, a faint reverberation of a massive explosion that offers a glimpse into the halo's turbulent past. Stay with us as we continue our journey through the Andromeda Galaxy's hidden wonders. Now, let's turn our attention to a phenomenon that feels almost like a whisper from the past, the cosmic echo. This faint reverberation, detected in the Andromeda Galaxy's halo, is the lingering aftermath of a massive explosion that occurred billions of years ago. It's a ghostly reminder of the violent events that have shaped the halo over time, offering us a rare glimpse into its turbulent history. The origins of this cosmic echo trace back to an ancient cataclysm, likely a supernova or a collision between massive celestial bodies. Such events release an enormous amount of energy, sending shockwaves rippling through space. Over time, these shockwaves interact with the surrounding gas and dust, creating ripples that persist long after the initial explosion. These ripples, or echoes, are what astronomers have detected in the halo, providing a snapshot of the chaos that once unfolded there. Detecting this echo was no small feat. Astronomers used advanced instruments to measure subtle changes in the halo's light and radio emissions. By analyzing these signals, they identified patterns that matched the expected signatures of an explosion's aftermath. The echo appears as faint variations in the halo's brightness and spectral lines, revealing the presence of shockwaves that have traveled vast distances over eons. What makes this discovery so fascinating is what it tells us about the halo's history. The cosmic echo suggests that the halo was once a far more dynamic and violent place than it appears today. Massive explosions and collisions were likely common, shaping the distribution of gas, dust, and stars in ways that still influence the halo's structure. By studying this echo, scientists can piece together the sequence of events that transformed the halo into the relatively calm region we observe now. Moreover, the cosmic echo provides clues about the chemical evolution of the halo. The explosion that created it would have scattered heavy elements like iron and silicon into the surrounding space, enriching the halo's gas and dust. These elements are essential for the formation of planets and life, making the echo not just a relic of destruction, but also a key to understanding the building blocks of the universe. As we listen to this faint echo from the past, we're reminded of the Andromeda Galaxy's halo as a living record of cosmic history. It's a place where the echoes of ancient explosions still resonate, offering us a chance to uncover the secrets of a bygone era. Next, we'll dive into the swirling chaos of the galactic vortex, a mesmerizing whirlpool of gas and stars that reveals the dynamic forces at work in the halo. Stay with us as we continue to unravel the mysteries of the Andromeda Galaxy's hidden wonders. Now, let's shift our gaze to a breathtaking spectacle in the Andromeda Galaxy's halo, the galactic vortex. This swirling whirlpool of gas and stars is a mesmerizing display of cosmic forces at work, offering a glimpse into the dynamic processes that shape the halo's structure. The galactic vortex is thought to form when massive clouds of gas and dust are pulled into a spinning motion, often triggered by gravitational interactions with nearby galaxies or the remnants of past collisions. As these materials spiral inward, they create a vortex-like structure with stars and gas swirling around a central point. This process can take millions of years, resulting in a stunning celestial dance that defies imagination. Detecting this vortex required a combination of advanced telescopes and precise measurements. Astronomers used observations in visible light, radio waves, and infrared to map the movement of gas and stars within the halo. By analyzing the patterns of motion, they identified the telltale signs of a vortex spiraling arms of gas and stars, along with regions of intense star formation at its edges. These observations revealed not only the vortex's structure, but also its influence on the surrounding environment. The galactic vortex plays a crucial role in the halo's dynamics. As gas and stars are drawn into the vortex, they compress and heat up, triggering the birth of new stars. This process enriches the halo with young, bright stars, altering its overall composition and appearance. Additionally, the vortex's gravitational pull can disrupt the orbits of nearby objects, redistributing material across the halo and contributing to its ever-changing structure. What makes this vortex particularly fascinating is its connection to larger galactic processes. It serves as a natural laboratory for studying how gas and stars interact under extreme conditions, shedding light on the mechanisms that drive star formation and galactic evolution. By understanding the vortex, scientists can gain insights into how similar structures might form in other galaxies, including our own Milky Way. As we marvel at this swirling cosmic wonder, we're reminded of the halo's dynamic nature, a place where gas, stars, and gravity come together to create breathtaking phenomena. The galactic vortex is not just a beautiful sight, it's a testament to the forces that shape the universe on the grandest scales. Next, we'll explore a region where light seems to vanish, a mysterious cosmic shadow that challenges our understanding of the halo's darkest corners. Stay with us as we continue our journey through the Andromeda Galaxy's hidden wonders. Now, let's turn our attention to one of the most enigmatic phenomena in the Andromeda Galaxy's halo, the cosmic shadow. This mysterious region where light appears to vanish challenges our understanding of how light and matter interact in the vastness of space. The cosmic shadow was first detected when astronomers noticed an unusual absence of light in a specific area of the halo. Unlike typical dark regions caused by dust clouds blocking starlight, this shadow seemed to absorb light without any visible obstruction. Observations using multiple wavelengths of light, from radio waves to X-rays, revealed that the shadow was not just a void but a region where light was being absorbed or redirected in ways that defied conventional explanations. One leading theory suggests that the cosmic shadow could be caused by an extremely dense concentration of dark matter. Dark matter, which does not emit or reflect light, could be bending or trapping light in this region, creating the illusion of a shadow. Another possibility is the presence of an exotic form of matter or energy that interacts with light in ways we have yet to fully understand. Some scientists have even speculated about the existence of microscopic black holes or other compact objects that could be absorbing light on a massive scale. The discovery of the cosmic shadow has profound implications for our understanding of light and matter. It raises questions about the nature of dark matter and whether it can interact with light in ways we haven't observed before. If dark matter is indeed responsible for this phenomenon, it could provide new clues about its properties and how it shapes the universe on both small and large scales. Additionally, the cosmic shadow challenges our assumptions about the behavior of light in extreme environments. It suggests that there may be regions in space where light behaves in ways that contradict our current models of physics. Studying this shadow could lead to breakthroughs in our understanding of fundamental forces and particles, potentially uncovering new aspects of the universe that have remained hidden until now. As we continue to explore the Andromeda Galaxy's halo, the cosmic shadow stands as a reminder of how much we still have to learn about the cosmos. It's a puzzle that invites us to rethink our understanding of light, matter, and the invisible forces that shape the universe. Next, we'll venture into the space between galaxies to uncover a rare and fascinating object, an intergalactic nebula. Stay with us as we continue to unravel the mysteries of the Andromeda Galaxy's halo. Now, let's journey into the vast expanse between galaxies to uncover one of the rarest phenomena in the Andromeda Galaxy's halo, the Intergalactic Nebula. Unlike typical nebulae found within galaxies, this cosmic cloud exists in the lonely void between them, making it a true anomaly in the universe. The Intergalactic Nebula was first detected during a survey of the Andromeda Galaxy's halo, where astronomers noticed a faint, glowing patch of gas that didn't seem to belong to any nearby galaxy. Using advanced telescopes capable of capturing light across multiple wavelengths, they confirmed that this glowing cloud was not part of Andromeda or any other galaxy, but was instead floating freely in intergalactic space. This nebula is composed primarily of hydrogen and helium, the building blocks of the universe, along with traces of heavier elements like oxygen and nitrogen. What makes it particularly fascinating is its isolation. Most nebulae form within galaxies, where they are often associated with star formation or the remnants of dying stars. But this intergalactic nebula exists far from any galaxy, raising questions about its origins. One theory suggests that it could be the leftover material from a galactic collision. When galaxies collide, vast amounts of gas can be ejected into intergalactic space, forming clouds like this one. Another possibility is that it's a remnant of the early universe, a relic from a time when the cosmos was filled with diffuse gas before galaxies fully formed. The rarity of intergalactic nebulae makes them incredibly valuable for astronomers. They offer a unique opportunity to study the conditions of the universe outside the influence of galaxies, providing insights into the processes that shape the cosmos on the largest scales. By analyzing the composition and structure of this nebula, scientists hope to learn more about the distribution of matter in the universe and the forces that drive its evolution. As we continue to explore the Andromeda Galaxy's halo, the Intergalactic Nebula stands as a testament to the unexpected wonders that await us in the vastness of space. It's a reminder that even in the emptiness between galaxies, there are mysteries waiting to be uncovered. Next, we'll delve into the final and most perplexing object in our journey, a phenomenon that defies all current explanations. Stay with us as we approach the conclusion of our exploration into the strange and mysterious objects of the Andromeda Galaxy's halo. As we reach the final chapter of our exploration, we encounter the most enigmatic object in the Andromeda Galaxy's halo, a phenomenon that has left astronomers utterly baffled. This mysterious entity, simply referred to as the final mystery, defies all known laws of physics and challenges our understanding of the cosmos. The final mystery was first detected as a faint, irregular signal emanating from the outer reaches of the halo. Unlike anything previously observed, this signal fluctuates unpredictably, appearing and disappearing without any discernible pattern. Its emissions span across multiple wavelengths, from radio waves to gamma rays, yet no known celestial object matches its unique signature. What makes this phenomenon even more perplexing is its apparent lack of a physical form. Unlike stars, black holes, or nebulae, the final mystery doesn't seem to have a defined structure or location. Instead, it behaves almost like a ghostly presence, detectable only through its sporadic bursts of energy. Some scientists speculate that it could be a new type of cosmic object, one that exists outside our current framework of astrophysics. Theories about its origins range from the plausible to the extraordinary. One hypothesis suggests it could be a manifestation of dark energy, the mysterious force driving the universe's expansion. Another proposes that it might be a remnant of a higher dimensional object, leaking energy into our three-dimensional space. There's even the tantalizing possibility that it could be evidence of advanced extraterrestrial technology, though this remains purely speculative. Despite decades of observation and analysis, the final mystery remains unsolved. Its unpredictable nature makes it nearly impossible to study in detail, and every attempt to explain it only raises more questions. Yet, this very elusiveness is what makes it so valuable to science. It serves as a stark reminder that the universe is far more complex and mysterious than we can currently comprehend. As we conclude our journey through the strange and wondrous objects of the Andromeda Galaxy's halo, the final mystery stands as a symbol of the endless frontiers of discovery that await us. It challenges us to keep exploring, to keep questioning, and to remain open to the possibility that the cosmos holds secrets we have yet to imagine. Thank you for joining us on this incredible adventure through the Andromeda Galaxy's halo. If you enjoyed this exploration of cosmic mysteries, don't forget to like, subscribe, and hit the notification bell for more deep dives into the wonders of the universe. Until next time, keep looking up. The stars have so much more to reveal. As we wrap up this journey through the Andromeda Galaxy's halo, it's impossible not to marvel at the sheer diversity and strangeness of the 50 objects we've explored. From ghostly nebulae and rogue black holes to mysterious radio sources and cosmic echoes, each discovery has pushed the boundaries of our understanding and left us with more questions than answers. These objects are not just curiosities, they are windows into the deeper workings of the universe, challenging us to rethink what we know about space, time, and the very fabric of reality. The Andromeda Galaxy's halo is a treasure trove of cosmic mysteries, a place where the ordinary becomes extraordinary and the impossible seems just within reach. It reminds us that, even with all our advancements in science and technology, the universe still holds secrets that defy explanation. The final mystery, in particular, stands as a testament to the endless wonder of the cosmos, urging us to keep exploring, keep questioning, and keep dreaming. But the story doesn't end here. Every discovery we make opens new doors, and every mystery we solve reveals even more to explore. The Andromeda Galaxy's halo is just one corner of the vast universe, and who knows what other strange and wondrous objects await us out there. We'd love to hear your thoughts on these cosmic enigmas. What do you think the final mystery could be? Do you have your own theories about the strange objects in the Andromeda Galaxy's halo? Share your ideas in the comments below. We're excited to hear your perspectives and spark even more curiosity about the universe. If you enjoyed this deep dive into the mysteries of space, don't forget to like this video, subscribe to our channel, and hit the notification bell so you never miss an update. There's so much more to discover, and we can't wait to take you on the next adventure. Until then, keep looking up. The stars are always waiting to reveal